we get busier in the ocean, we need to provide adequate infrastructure and equipment to make sure everything goes well. So, come with me and explore ocean engineering together.
Welcome to the Ocean Engineering Department, Institut Teknologi Sepuluh Nopember. As the pioneer of ocean engineering education in Indonesia, we provide the best education to shape the graduate in the field of construction, maintenance, and the development of onshore and offshore structures. The future of ocean relies on its sustainability that we learn about ocean renewable energy and environment. Balancing the development of technology, we also learn about marine digitalization.
Established in 1983, Ocean Engineering is part of the Marine Engineering Faculty, Institut Teknologi Sepuluh Nopember.
Merupakan sekretaris program studi teknik kelautan yang didirikan tahun 1983 yang pertama kali, kemudian mengawal sampai menjadi jurusan teknik kelautan yang di-establish didirikan tahun 1985. Kemudian bersama-sama ITB kita menerima program bantuan dari Dikti melalui support Bank Dunia atau World Bank 17 menjadi program S1 Ocean Engineering.
The education quality has been accredited A by Indonesian Accreditation Board for Engineering Education and National Accreditation Board for Higher Education. Our vision is to be a higher education institute. Engineering, bachelor's degree in offshore engineering, and doctoral degree in ocean engineering science.
Our department is supported by professional educators, including 4 professors, 17 doctors, and 6 magisters to reach our vision and mission. To support the research and education development, there are 6 laboratories in ocean engineering. So, let's see the activities in each laboratory.
This laboratory is expected to be able in research and development of structure and material such as bending test, tensile test, and medi-board. The main facility in this laboratory is a towing tank that can be used for measurement of ship resistance, seakeeping testing, and maneuvering on a limited scale. This laboratory is also equipped with the computational fluid dynamics. Laboratory of Coastal and Marine Environment with all supporting facilities, this laboratory is ready to provide services in the use and management of coastal and marine resources in the field of research, surveys, and technical consulting. Center of Marine Environment, Marine Energy, and Coastal Engineering Development. This laboratory is equipped with a flume tank, wave, current, and wind generator. This computational laboratory serves to support practicums from several subjects, including computational programming, numerical analysis, tide, and coastal structure design. This laboratory focuses on analysis in ocean structure, flexible structure, operation analysis, also optimization, risk, and reliable base design. We support student interest in social activities with 6 student organizations as soft skill development. Besides, we also have many publications and conference activities to give more insight and discussion about ocean engineering outside class learning. Ocean engineering students have received several awards in national and international competitions such as paper, Olympic design, case study, and Ocean Film Festival. Ocean engineering has been collaborating with other education institutions in national and international government and industry companies. The purpose of this relation to improve the hard skill by joint research, focus group discussion, internship, and other events. With all supporting facilities and activities in academic, also collaboration that have been built, the graduates of Ocean Engineering ITS are expected to make careers oil and gas industry, onshore and offshore structure companies, governmental and non-governmental organizations. More than 80% of the Ocean Engineering graduates have been hired in 6 months after graduation.
Departemen Teknik Kelautan, Fakultas Teknologi Kelautan ITS telah lama berperan untuk pembangunan kelautan di Indonesia. Dan di masa depan, peran ini akan semakin penting, terutama di dalam melahirkan lulusan-lulusan yang akan siap dalam merancang, membangun, mengoperasikan, dan merawat bangunan-bangunan laut, baik itu untuk mendukung pembangunan eksplorasi sumber daya kelautan, untuk mendukung produksi minyak dan gas di lepas pantai, untuk melindungi pantai dari kerusakan-kerusakan, untuk pembangunan pulau-pulau kecil, maupun untuk mengeksplorasi sumber daya laut dalam yang selama ini belum dikelola. Indonesia di masa depan akan sangat tergantung dengan cadangan minyak dan gas yang ada di lautan yang makin jauh, yang selama ini masih sulit, dan itu membutuhkan kemampuan teknologi kelautan. Kawan-kawan dan dari seluruh Indonesia akan memiliki kemampuan yang cukup untuk mengelola kekayaan negeri ini dengan teknologi kelautan. Terima kasih.
So, have you got better insight of our department? To know more about us, visit our website. Let's join with us and together build of our ocean.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, and greeting to us all. First of all, let's offer our worship and gratitude to the Almighty God who has given us health and sustenance so that we can gather virtually on this day. Please allow me to introduce myself. My name is Lutfan Taufik Lapis, as matter ceremony for today. I am very happy to welcome all the audience at the 9th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, or ISOCEEN 2021. With this year's theme is promoting ocean coastal engineering, innovation, and collaboration for sustainable development. Without lingering any longer, I will read the schedule for today. First, there is an opening. Second is recitation of prayer. Third is singing the national anthem of Indonesia Raya, continued by hymn of ITS. Then there are welcome remarks, launching of Consortium Teknik Kelautan Indonesia. Then there are presentation from the first keynote, Prof. Omar bin Yaakob, Ph.D. from Universiti Teknologi Malaysia. Then the presentation from Professor Takeshi Shinoda, Ph.D. from Kyushu, Japan. Then there is a break. Continue with the third presentation from Dr. Shahrin Osman, DBA from GNV Maritime Region, Southeast Asia, Pacific, and India. And then for the last presentation from Mr. Iqbal Fikri, Master Science from PT PAL Indonesia. Then there is closing. Next, we will enter the second schedule. Let's pray together for today's event so we can go well. Praying begin. Praying finish. Next is singing the national anthem of Indonesia Raya, continued by hymn of ITS. All the audience, please stand. Continue by hymn of ITS. To our next schedule, there is the first welcome remarks from the head of ITS Maritime Technology Faculty, Dr. Trika Pitana. The time and place is yours.
Bismillahirrahmanirrahim. Excellency, Vice Dean and Head of Department of Engineering, distinguished keynote speakers, Professor Omar Yaakob, Ph.D. from UT Malaysia, Professor Takeshi Shinoda, Ph.D. from Kyushu University-Japan, Bapak Iqbal Fikri, S.E.A, M.Sc, Production Director of Vitipal Indonesia, Dr. Shahrin Osman, BBA from the DNV Maritime Region, S.E.A, Pacific and India, Chairman of ISOCEEN 2021, Professor Daniel M. Rosyid, all invited speakers, all delegation, Konsorsium Teknik Kelautan Indonesia, from ITB, ITERA, ITK, and UNHAS, contributing authors, seminar delegates, experts, scholars, all students, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to welcome to all of you to the opening ceremony of the 9th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, or usually called as ISOCEEN 2021. ISOCEEN 2021 is annually international seminar held by the Ocean Engineering Department, and this event is the second time which is conducted virtually because of the pandemic COVID-19. I'm very happy and believe that many people who join this seminar have the high academic and professional reputation. I'm very pleased and honored to join you during the opening the seminar with themes promoting oceans coastal engineering innovation and collaboration for sustainable development. The conference mainly will discuss several topics such as ocean and coastal engineering, environmental and natural disaster management, and also related topics. I do believe that this seminar can be a platform for exchanging information and experience, as well as sharing the result of research, especially in relation to the latest development and innovation for ocean and coastal management. Furthermore, I believe that all participants will be benefit greatly from this activity and expected to be spreading positive impact to raise awareness on the potential new technology for the development of maritime sector. Last but not the least, let me give and express sincere appreciation to all speakers contributing to the seminar. Special thanks are also to all great speakers, invited speakers, and committee for the effort in preparing the manuscript and also managing this session respectively. Last, I wish to warmly thank our hosts for their dedication in preparing important international seminar, and notably Chairman of ISOCEEN 2021, Professor Daniel M. Rosyid, and all organizing committee from Department of Ocean Engineering. I wish the seminar a complete success. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi and a very good morning to all of you all. Ladies and gentlemen, respected speakers, colleagues, and friends, I'm happy to be here as the chairman of the 9th ISOCEEN 2021 to welcome you to this international event that we at the Department of Ocean Engineering of ITS are proud of. The theme of this ISOCEEN 2021 is promoting ocean and coastal engineering innovation and collaboration for sustainable development. This topic proves to be of common global interest. Our ocean and coastal activities and products have to adopt a more committed thoughts and efforts to make sure that we achieve the sustainable development goals through reducing carbon emission. These global challenges requires a global collaborative efforts to respond effectively. Both the industry community and the academia have to work hand on hand with the government to make the right response in some sustainable manner. Let me share and remind you all that Indonesia is a vast archipelagic country. Its vastness spread from Glasgow in the north tip of Sumatra to Istanbul and Merauke of Papua. Almost 70% of this vast part of the planet is water. The challenges in transforming this into a value-adding renewable resources is tantamount to our prosperous and sustainable future. We are going to witness the official signing of a new effort called the Ocean Engineering Consortium of Indonesia, which involves at its beginning 5 prominent institutions of higher education. The objectives of this ISOCEEN 2021 therefore has been partly realized. We do hope that the consortium will grow as we learn and take roles together in responding to the challenges for our more sustainable future. I'm happy also to have 4 keynote speakers that will address this theme in different perspectives. The first is Prof. Omar Yaakob of UTM, Malaysia. We'll be talking on maritime community contribution to a more sustainable future. Second, Professor Takeshi Shinoda of Kyushu University will be talking on the future of carbon neutral ports. The third is Dr. Shahrin Osman of the NP Asia Pacific and India. We'll be talking on collaboration as the fuel of shaping decarbonization. And the fourth is Mr. Iqbal Fikri of Fikri, Indonesia. We'll be talking on opportunities for collaboration, Indonesia, blue economy, a maritime industry perspective. Ladies and gentlemen, on behalf of the committee, I thank to the 4 keynote speakers who have made themselves available to share with us their knowledge, views, and experiences. While I'm looking forward to see a joint efforts between the maritime industries, academia, and the government, last but not least, I thank you for the participations of the audiences, students, lecturers of ISOCEEN 2021, the academic staffs of the department, and the students who have made this seminar possible. I do hope that you will find the seminar interesting, enriching your horizon, and inspiring your mind and souls. Thank you very much indeed. Assalamualaikum warahmatullahi wabarakatuh.
Consortium Teknik Kelautan Indonesia. There's chairman speech from Consortium Teknik Kelautan Indonesia for Mr. Herman Pratikto, Ph.D. The time and place is yours.
Warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Ladies and gentlemen, allow me in this opportunity to welcome all of these webinar participants by first praying our grateful and praise to the Almighty God for His blessing, grace, and mercy that have made us possible to gather here in this room in excellent condition and health. Dear keynote speakers, invited speakers, distinguished guests, and participants of the 9th International Conference on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, or ISOCEEN, with topic on promoting ocean coastal engineering innovation and collaboration for sustainable development. Institut Teknologi 10 November ITS is very pleased to host this conference in Surabaya. Welcome to ITS campus. Welcome to Surabaya City. I especially thanks to the organizing committee for their hard work, perseverance, and patience in preparing and organizing this seminar so that it can go well, smoothly, and successfully. Finally, through this webinar, let us extend the network and cooperation among all stakeholders of the ocean technology sector, especially in Indonesia, in the world in general, to build a better to all our distinguished guests and participants. Thank you for being here. Welcome and enjoy the webinar. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
ocean research as we have more than 3 million kilometers square.
First all of, let us thank God, the Almighty who has given His grace and guidance to that launch of the Indonesian Ocean Engineering Consortium be held successfully. The Ocean Engineering Consortium is an organization that brings together higher education institutions in the field of ocean engineering, especially in Indonesia. This consortium is motivated by the spirit of togetherness to support each other in exchange of science and technology through the utilization of resources owned by the consortium members in the field of education, research, and community service. This need to be realized considering the challenge of development in the field of ocean engineering are very broad and require greater resources. This consortium aims to encourage scientific development in the field of ocean engineering in an effort to provide solutions to the need of the state of Indonesia in the present and the future regarding the provision of facilities and technology to utilize and manage Indonesian ocean areas. It is also hoped that the mainstreaming of ideas in solving multi-sectoral problem of ocean engineering consortium, Institut Teknologi Bandung, Universitas Hasanuddin, Institut Teknologi Kalimantan, Institut Teknologi Sumatera, Institut Teknologi 10 November, for their hard work, preference, and passion in preparing and organizing this consortium so that it can go well, smoothly, and successfully. Finally, through this consortium, let us extend the network and cooperation among all stakeholders of the ocean technology sector, especially in Indonesia and in the world in general, to build a better maritime world in Indonesia. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
And then next, there is signing of agreement of Consortium Teknik Kelautan Indonesia. Consortium di itu. Next, there is signing of agreement from each Department of Ocean Engineering of Indonesia for all members of Consortium Teknik Kelautan Indonesia. There is signing of agreement and there is in photo from the chairman. This is a member of Consortium Teknik Kelautan Indonesia from ITS, ITB, ITERA, Unhas, TK, signing Women's Day. So signing is finished. Let's continue with the photo session. Next, there will be a speech from Campus Representation of Consortium Teknik Kelautan Indonesia. And for the first representation, there is Dr. Khairul Kautanant from Universitas Hasanuddin. The time and place is yours.
Assalamualaikum warahmatullahi wabarakatuh. Distinguished ladies and gentlemen, first of all, I would like to say thank you for the Master of Ceremony who has given me this time to deliver my speech in this morning. But I'm sorry because I will deliver my speech in Bahasa because I have not prepared my speech in English. Bapak Ibu yang saya hormati, terima kasih atas waktu yang diberikan kepada kami untuk menyampaikan sedikit sambutan terkait dengan pembentukan konsorsium teknik kelautan Indonesia yang kita telah diskusikan beberapa kali, kalau tidak salah 2 atau 3 kali secara formal. Pada dasarnya kami Universitas Hasanuddin dalam hal ini Departemen Teknik Kelautan menyambut baik ide dan gagasan dari teman-teman yang ada di Institut Sepuluh Nopember Surabaya, dalam hal ini Pak Herman dan kawan-kawan terkait dengan pembentukan konsorsium ini. Tentu saja konsorsium ini tujuannya sangat mulia, sangat baik, dan kedepannya akan kita gunakan atau kita manfaatkan sebagai media untuk bersinergi, bukan berkompetisi tapi bersinergi dalam hal pembangunan kelautan di Indonesia dari berbagai sudut pandang, baik dari sumber daya manusia maupun pengelolaan sumber daya alam dan pembangunan sektor kelautan di Indonesia. Harapan kami dari Departemen Teknik Kelautan, melalui konsorsium ini kita bisa mendapatkan benefit baik dalam ranah pengembangan ilmu dan pengetahuan di kampus masing-masing maupun dalam hal berkontribusi terhadap pembangunan di sektor kelautan di negara yang kita cintai ini, yang merupakan negara kepulauan. Saya selalu berpikir bahwa Indonesia memang terdiri dari beberapa ribu pulau yang dipisahkan oleh lautan. Marilah kita memandang laut ini bukan sebagai pemisah, tetapi laut adalah pemersatu. Marilah kita pandang laut ini sebagai sebuah piring besar yang dapat kita manfaatkan, kita kelola untuk kemaslahatan rakyat, bangsa, dan negara kita. Kita anggap bahwa piring besar ini akan dinikmati oleh orang Sumatera, akan dinikmati orang Jawa, Kalimantan, Sulawesi, Maluku, Nusa Tenggara, Bali, Papua, dan sebagainya. Jadi sekali lagi, keberadaan atau terbentuknya konsorsium teknik kelautan ini mudah-mudahan akan memberikan benefit yang luar biasa bagi bangsa Indonesia. Demikian apa yang bisa saya sampaikan. Kami Universitas Hasanuddin melalui Departemen Teknik Kelautan menyatakan bahwa kami sangat mendukung pembentukan konsorsium teknik kelautan Indonesia. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
And the next campus representation, there is Dr. Hendriawan from ITB. The time and place is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Semoga kita senantiasa dalam kesehatan selalu. Pertama-tama saya sampaikan terima kasih atas kesempatan yang diberikan pada Ketua Panitia, ISOCEEN, kemudian para Kaprodi maupun Ketua Departemen atau Ketua Jurusan Program Studi Teknik Kelautan di Indonesia. Terima kasih atas kesempatan yang diberikan. Mungkin tidak banyak yang bisa saya tambahkan dalam kesempatan ini karena sudah banyak tadi disampaikan oleh Ketua Konsorsium dan juga dari Hairul sebelumnya dari Prodi dari Universitas Sepuluh. Kemudian semoga harapan kami semoga proses pembentukan konsorsium ini dimudahkan oleh Allah Subhanahu Wa Taala, Tuhan Yang Maha Kuasa, dan dengan harapan konsorsium ini dapat mewujudkan sinergi antara perguruan tinggi Indonesia khususnya program studi teknik kelautan dalam hal pendidikan, penelitian, dan pengabdian kepada masyarakat, serta mendorong kemajuan ilmu teknik kelautan di Indonesia. Saya dari atas nama Program Studi Teknik Kelautan Institut Teknologi Bandung mendukung konsorsium ini, semoga kedepannya makin bersinergi dengan seluruh perguruan tinggi di Indonesia, khususnya di bidang teknik kelautan. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
And from the next speech, there is Mr. Nanda Nurisman from ITERA. The time and place is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Alhamdulillah, di pagi hari ini kita masih diberikan kesehatan Allah Subhanahu wa Ta'ala. Saya mewakili dari Program Studi Teknik Kelautan Institut Teknologi Sumatera menyambut baik dan sangat mendukung terbentuknya konsorsium Teknik Kelautan Indonesia. Melalui konsorsium ini kita dapat bekerja sama, berkolaborasi dalam kegiatan pendidikan melalui sharing facility, kemudian dalam kegiatan penelitian dan pengabdian kepada masyarakat, Semoga apa-apa yang telah kita sepakati bersama di dalam konsorsium dapat berjalan dengan baik. Demikian dari saya mewakili program studi teknik kelautan Institut Teknologi Sumatera. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi.
And from the last speech, there is Mrs. Siti Ayuningsi from ITK. The time and place is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi untuk Bapak Ibu dan seluruh komite dari ISOCEEN dan member dari Teknik Kelautan Konsorsium. Di sini saya mewakili Ibu Rima Diana Harahap sebagai Prodi dari Teknik Kelautan ITK Teknologi Kalimantan. Harapannya dari adanya konsorsium ini kami bisa berkontribusi dengan baik, lakukan yang terbaik gitu ya. Kemudian yang kami harapkan konsorsium ini bisa memberikan dampak untuk tridharma perguruan tinggi, mulai dari penelitian, pengabdian masyarakat dan pendidikan. Kemudian kami sangat berterima kasih karena telah dilibatkan ke dalam member dari konsorsium ini. Di akhir kata, karena tidak banyak yang bisa saya sampaikan, wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Before we continue to our next schedule, let's see the profile video from each Ocean Engineering Department of Konsorsium Teknologi Indonesia.
Ribuan pulau terbentang dari Sabang hingga Merauke dan berada di garis khatulistiwa, Indonesia dikaruniai kekayaan alam yang sangat melimpah. Dengan luas daerah yang 2/3-nya adalah laut, menjadikan Laut Indonesia sebagai salah satu potensi terbesar dalam perkembangan ekonomi menuju Indonesia yang lebih maju. Untuk mewujudkan cita itu, Indonesia membutuhkan generasi-generasi muda yang ahli dalam bidang ilmu teknologi kelautan. Universitas Hasanuddin merupakan salah satu universitas terbaik di Indonesia yang berdiri pada tahun 1960. Terletak di kota Makassar menjadikan Universitas Hasanuddin sebagai universitas terbaik di Indonesia bagian timur dan menduduki peringkat ke-8 sebagai universitas terbaik seluruh Indonesia. Saat ini, Universitas Hasanuddin tercatat memiliki 16 fakultas, 62 program studi serata 1, dan 36 program studi magister. Departemen Teknik Kelautan menjadi salah satu program studi yang sangat berpengaruh dalam pengembangan sektor maritim Indonesia. Mahasiswa-mahasiswa Departemen Teknik Kelautan mempelajari hal-hal yang berkaitan dengan rekayasa bangunan laut, seperti pelabuhan, breakwater, dan offshore.
Program studi Teknik Kelautan Fakultas Teknik Universitas Hasanuddin memiliki visi yaitu menjadi pusat institusi pendidikan unggulan yang berkelanjutan dalam ilmu pengetahuan dan teknologi kelautan dengan wawasan lingkungan kebaharian. Sedangkan misinya adalah yang pertama, meningkatkan kuantitas dan kualitas tridharma perguruan tinggi secara berkelanjutan untuk menunjang kehidupan masyarakat. Yang kedua, menciptakan atmosfer akademik dalam peningkatan ilmu pengetahuan, teknologi, dan seni berbasis riset. Dan yang ketiga, adalah mengembangkan kemampuan jaringan global melalui kerjasama dengan institusi pendidikan, pemerintah dan industri pada tataran lokal, nasional, regional, dan internasional. Kurikulum program studi teknik kelautan dibagi atas 4 peminatan atau konsentrasi. Yang pertama adalah Labo Teknologi Lepas Pantai. Yang kedua, Labo Manajemen Produksi Bangunan Lepas Pantai. Yang ketiga, Labo Pantai dan Lingkungan. Dan yang keempat adalah Labo Pelabuhan. Keempat, labo tersebut atau peminatan tersebut didukung oleh fasilitas laboratorium yang canggih dan lengkap.
Selamat datang di Laboratorium Teknologi Kelautan Departemen Teknik Kelautan Fakultas Teknik Universitas Hasanuddin. Laboratorium Teknologi Kelautan di bawah kendali Departemen Teknik Kelautan Fakultas Teknik Universitas Hasanuddin telah memiliki peralatan-peralatan mutakhir untuk dipergunakan pada survei-survei dan penelitian-penelitian dosen, baik itu di lingkup pemerintahan, swasta, maupun perorangan. Peralatan yang paling mutakhir yang kami punyai adalah sebuah flam tank dengan ukuran panjang 24 meter, lebar 1 meter, tinggi 1 meter, yang mempunyai flap wave maker dengan artificial intelligence, mampu melakukan uji gelombang secara terus-menerus dengan tetap ada gelombang pada parameter yang sama. Selain daripada itu, kami telah melakukan banyak sekali kegiatan, puluhan pekerjaan lapangan berupa survei-survei tentang rencana induk pelabuhan, tentang bangunan-bangunan pelindung pantai, bahkan tentang AMDAL. Yang paling menarik adalah kami terakhir ini melakukan desain dekoder di Pertamina di Serui, Papua, serta pada tahun 2021 kami diminta untuk melakukan desain dermaga apung di rencana Ibu Kota Negara.
Departemen Teknik Kelautan selain memiliki peralatan laboratorium, juga memiliki peralatan survei lapangan yang relatif lengkap dan canggih. Oleh sebab itu, beberapa kerjasama antara Center of Technology Universitas Hasanuddin dengan mitra dari industri dan instansi pemerintah telah memanfaatkan peralatan survei dan sumber daya manusia dari
will we get? How important the future of ocean engineer to Indonesia?
Indonesia has enormous potential in ocean research as we have more than 3 million kilometers square. Of course, the professionals in marine development are needed. As we get busier in the ocean, we need to provide adequate infrastructure and equipment to make sure everything goes well. So, come with me and explore ocean engineering together.
Welcome to the Ocean Engineering Department, Institut Teknologi Sepuluh Nopember. As the pioneer of ocean engineering education in Indonesia, we provide the best education to shape the graduate in the field of construction, maintenance, and the development of onshore and offshore structures. The future of ocean relies on its sustainability that we learn about ocean renewable energy and environment. Balancing the development of technology, we also learn about marine digitalization.
Established in 1983, ocean engineering is part of the Marine Engineering Faculty, Institut Teknologi Sepuluh Nopember.
Merupakan sekretaris program studi teknik kelautan yang didirikan tahun 1983 yang pertama kali, kemudian mengawal sampai menjadi jurusan teknik kelautan yang di-establish atau didirikan tahun 1985. Kemudian bersama-sama ITB kita menerima program bantuan dari Dikti melalui support Bank Dunia atau World Bank 17 menjadi programnya S.E.A Ocean Engineering.
The education quality has been accredited A by Indonesian Accreditation Board for Engineering Education and National Accreditation Board for Higher Education. Our vision is to be a higher education institution of ocean engineering in international level that become a reference in Southeast Asia. Our missions are organizing higher education in ocean engineering to the younger generation, conducting innovative and qualified research of ocean engineering science, also responsive to the development of community problem solving in national and global scope, to provide science-based ocean engineering services for government, industry, and society. Ethically, manage the department effective, efficient, transparent, and accountable. We offer bachelor's degree and master's degree in ocean engineering, bachelor's degree in offshore engineering, and doctoral degree in ocean engineering science.
Our department is supported by professional educators, including 4 professors, 17 doctors, and 6 magisters to reach our vision and mission. To support the research and education development, there are 6 laboratories in ocean engineering. So, let's see the activities in each laboratory. This laboratory is expected to be able in research and development of structure and material such as bending test, tensile test, and many more. The main facility in this laboratory is a towing tank that can be used for measurement of ship resistance, seakeeping testing, and maneuvering on a limited scale. This laboratory is also equipped with the computational fluid dynamics. Laboratory of Coastal and Marine Environment with all supporting facilities, this laboratory is ready to provide services in the use and management of coastal and marine resources in the field of research, surveys, and technical consulting. Center of Marine Environment, Marine Energy, and Coastal Engineering Development. This laboratory is equipped with a fluid tank, waves, current, and wind generator. This computational laboratory serves to support practicums from several subjects, including computational programming, numerical analysis, tide, and coastal structure design. This laboratory focuses on analysis in ocean structure, flexible structure, operation analysis, also optimization, risk, and reliable base design. We support student interest in social activities with 6 student organizations and soft skill development. Besides, we also have many publications and conference activities to give more insight and discussion about ocean engineering outside class learning. Ocean engineering students have received several awards in national and international competitions such as paper, audit design, case study, and Ocean Film Festival. Ocean engineering has been collaborating with other education institutions in national and international government and industry companies. The purpose of this relation to improve the hard skills by joint research, focus group discussion, internship, and other events. With all supporting facilities and activities in academic, collaboration that have been built, the graduates of Ocean Engineering ITS are expected to make careers oil and gas industry, onshore and offshore structure companies, governmental and non-governmental organizations. More than 80% of the Ocean Engineering graduates have been hired in 6 months after graduation.
Departemen Teknik Kelautan, Fakultas Teknologi Kelautan ITS telah lama berperan untuk pembangunan kelautan di Indonesia. Dan di masa depan, peran ini akan semakin penting, terutama di dalam melahirkan lulusan-lulusan yang akan siap dalam merancang, membangun, mengoperasikan dan merawat bangunan laut, baik itu untuk mendukung pembangunan eksplorasi sumber daya kelautan, untuk mendukung produksi minyak dan gas di lepas pantai, untuk melindungi pantai dari kerusakan-kerusakan, untuk pembangunan pulau-pulau kecil, maupun untuk mengeksplorasi sumber daya laut dalam yang selama ini belum dikelola. Indonesia di masa depan akan sangat tergantung dengan cadangan minyak dan gas yang ada di lautan yang makin jauh, yang selama ini masih sulit, dan itu membutuhkan kemampuan teknologi kelautan. Kawan-kawan dan dari seluruh Indonesia akan memiliki kemampuan yang cukup untuk mengelola kekayaan negeri ini dengan teknologi kelautan. Terima kasih.
So, have you got better insight of our department? To know more about us, visit our website. Let's join with us and together build of our ocean.
Institut Teknologi Kalimantan.
Visi dan misi Prodi Teknik Kelautan Institut Teknologi Kalimantan menjadi program studi yang memiliki keunggulan untuk pengembangan sumber daya dan potensi daerah dalam pembangunan Kalimantan dan Indonesia dalam bidang teknik kelautan pada tahun 2025.
Misi 1. Melaksanakan program pendidikan yang berorientasi pada kebutuhan dan kemajuan ilmu pengetahuan disiplin ilmu rekayasa kelautan untuk menghasilkan lulusan yang unggul. 2. Menyelenggarakan penelitian untuk mengembangkan ilmu pengetahuan dan teknologi di bidang teknik kelautan dalam pengembangan sumber daya dan potensi daerah Kalimantan dan memanfaatkan hasil penelitian dalam kegiatan pengabdian kepada masyarakat. 3. Mengembangkan kerjasama dengan instansi nasional maupun internasional yang berbasis teknologi kelautan. 4. Melaksanakan manajemen program studi yang kredibel, transparan, akuntabel, bertanggung jawab, dan adil.
studi teknik kelautan di ITH ada 4 unit cabang. Yang pertama, Marine Safety. Yang kedua, Management, Production and Inspection. Yang ketiga, Defense Contraction. Yang keempat, Offshore Hydrodynamics. Sebab itu, untuk prospek kerja setelah lulus teknik kelautan sangat luas, seperti yang pertama, Marine Engineer. Yang kedua, Offshore Engineer. Yang ketiga, Pipeline Engineer. Yang keempat, Coastal Engineer.
Without lingering any longer, I give the time and place to the moderator for the first keynote speaker. To Prof. Widi Agus Pratikto, Ph.D., the time and place is yours. For the first moderator, for the first keynote speaker, to Prof. Widi Agus Pratikto, Ph.D., the time and place is yours.
Okay. I would like to welcome Professor Omar bin Yaakob. Are you already in the room?
Yes, I'm here. Can you hear me?
Oh yes, sir. Thank you very much. Welcome to this 5th of November. Professor Yaakob will be present with title Maritime Community Contribution, a More Sustainable Future. Professor Omar bin Yaakob from Universiti Teknologi Malaysia in Johor Bahru, I believe.
Yes.
So welcome, and time is yours for 45 minutes sharp, and there will be question and answer after that for 15 minutes. So I'll get to moderate the session and will be accompanied with together with you. Thank you very much, and time is yours, Prof. Yaakob.
Assalamualaikum warahmatullahi wabarakatuh, and good morning. Can you hear me?
Yes, clear.
Okay. All right. Alhamdulillah, we send our praise to God for making us able to meet today, even though it's only online. But I'm very happy to be here together with our colleagues in Indonesia, and also some other speakers who are coming from some other parts of the world. First of all, I'd like to thank Professor Rosyid especially, and of course the Dean and all the whole community of ATS for inviting me to make this presentation. So the title of my presentation is Maritime Community Contribution to a More Sustainable Future. I believe this will be in line with the theme of ISOCEEN. This will be my presentation outline. I'll be talking about very briefly on ocean sustainability particularly, and 3 sustainability issues in maritime transportation, just to update us on the important issues that we are looking at when we deal with sustainability in the marine technology particularly. And then the third part, we look into the role of our maritime community. So what we have been doing or what we need to do. And I believe since we are in the research community mainly, we will look at the various aspects that we can generate research interest or research topics and for students and researchers to look into so that we can contribute to the more sustainable future from our respective role in the marine industry and the marine community. And finally, we'll be talking just a little bit about future ship designers and marine engineers, because we are also in the education community. We need to look into how we can improve the education and training of ship designers and marine engineers in the future, particularly from the aspects of sustainability. So first, the topic of ocean sustainability, we need to look into from the main definition of the sustainability and sustainable development. So the sustainability agenda, or the things that we are talking about, particularly, I think very recently, most of you or most of us are aware about COP21, COP26, COP, Conference of Parties. COP is Conference of Parties. These are parties to the Kyoto Protocol of the United Nations Conference on the Framework on Climate Change, which they meet every year. So this is the 26th meeting. The previous big meeting that they had was in Paris in 2021. So the issue of sustainability is not only dealing with environment. I think we need to be aware about that, because sustainability also deal about how we improve the economics, society, and also the impact on the society and the environment. So the environment should not, whatever that we do to protect the environment, for example, should not affect too much on the society, and also should not affect the running economics or operating economics, for example, in what we will look later in shipping. So we need to into that. So there should not be one at the expense of the other, with these three aspects of sustainability. Okay, but of course the previously we have been looking at economics a long time ago. Economics seems to be the one which is most important decision making criteria for making a lot of projects and so on, and also impact on the people. That means maybe you want to help the people or improve people well-being, then you do a lot of things, but not considering so much the environment. So when we come to sustainability now, we want to have a look not only on the green, not only on the blue society, not only the orange economics there, but also dealing to green environment. So this need to be balanced when we're doing things. Yeah. So since today, although we are supposed to talk about sustainability, we will deal more towards the environment, because I think this aspect is the one that needs to be stressed. Of course, we have a long day, then we can talk about all the three, but we have only about 45 minutes or 40 minutes now left for dealing with the sustainability. So we concentrate mainly on the environment. So again, if we look at the 17 Sustainable Development Goals, you will see that it is not only on the environment. It's about no poverty, no hunger, good health, quality education, gender equality, clean water, responsible consumption, reduce inequalities, innovation and infrastructure, good jobs, economic growth, partnership for the goals, peace and justice. Okay, and then there are only few which are directly maybe have more emphasis on the environment or the thing that we're talking about. Normally we talk about green technology and so on. One will be the number 7, clean energy. Number 11, sustainable cities. Number 7 is clean energy. Number 11, sustainable cities. Number 13, protect the planet. Number 14, life below water. And number 15, life on land. So these are the issues that are very much related directly to the environment as such. That means sustainability from the environmental aspect. The rest deals with society, or social impact, and also from the economics impacts. So when we deal with the ocean, normally we look at the impact of what we do on the ocean. So that's 14, life below water. And we go to ocean sustainability, then we look at healthy, how to keep the healthy seas and oceans. So we know like Indonesia, archipelagic waters of Indonesia, and also in our EEZ in our countries, we need to keep this healthy. Yeah. So what are the 5 areas that we need to look at? One, with protection of marine biodiversity, elimination of unsustainable fishing practices, reduction of marine pollution, monitoring of ocean acidification, and conservation of biodiversity in areas beyond national jurisdiction. So if you look at what we have in this document, these 5 points or these priority areas, we see that I'll try to cover or touch on number 1, number 3, and number 4. Protection of marine biodiversity, reduction of marine pollution, or monitoring of ocean acidification. Or I would say that we will look at how our activities in the marine industry, shipping, transportation, and what we do at sea are actually having an impact on number 1, number 3, and number 4. Okay. So the IMO, International Maritime Organization, has taken this as a very important agenda when they published this publication in 2013, Sustainable Maritime Transportation System, where they say that the accessible maritime transportation system entail partnership between government, shipbuilders, classification societies, manufacturers, R&D establishment, and academic institutions. So it is the role of us, particularly in the academic institutions, to look into how we can contribute to this sustainable maritime transportation system. Okay, what are the top three sustainability issues in maritime transportation? As we have seen just now in the previous slides, these are the top 3 that we see, and I would make it a bit bigger into looking at the ship and the environment, and how the ship and how it affect the environment. So these are once you put a ship at sea, then you'll have these issues. The issues of pollution from the ship itself, for example, from volatile organic compounds. Maybe you have cargo on board that vaporize. Okay, that damages the environment. Or you have oil and chemicals, which are maybe could be the fuel, could be the cargo, which is spilled on the sea. Garbage, waste, wash water, sewage, and so on. You know, the waste from the ship itself. Underwater noise. The engines is generating noise, and the propellers that is affecting the biodiversity. And the wake wash is coming from the ship, causing a river or seashore erosion. And then ballast water, because some ships carry ballast water, they take ballast water from one port and they release it in another port. And then the emissions. The emissions will have 2. First will be the pollution from NOx, SOx, and particulate matters. And the second one will be greenhouse gases. These 2 are actually different, although maybe some are not very much aware. They lump the thing together, because greenhouse gas is not considered as pollution. It's not polluting. Okay, particularly carbon dioxide is not considered as a pollution. The issue is not pollution, but the issue is more of global warming and so on. Okay, we'll deal with that later. So if you were to look at the potential contributors to environmental damage, as we have seen just now, then there will be these three aspects. Aspect number 1 will be marine pollution, okay, which is a group of, you see, the garbage and waste and sewage, oil, chemical, fuel, cargo, volatile organic compounds, emissions. And of course, the maritime community is beginning to become more concerned about underwater noise and also wake wash. Okay, although not to the same level as in the top 4. Okay, so the second part that we look at will be the greenhouse gas emission, mainly carbon dioxide, right? So this is the pollution, the marine pollution. Then the second part will be the carbon dioxide. And finally, number 3, this is what we talk about, biodiversity. You want to protect our biodiversity is the issue of ballast water, which is the invasion of alien species. So the alien species being carried from one place to another is going to affect biodiversity in our ports, in our regions. Okay, so this is something that we need to look at as engineers, as technologists, as scientists, how we can mitigate this, either from the design of the ship or from maybe the scientists will look at how to handle the transfer of this alien species from one place to the other. Okay, we look into more detail into each one of them, the issues at hand. Yeah. So these are the three areas that I mentioned just now. Number one would be marine pollution. Number two, invasion of alien species. And number three, be carbon dioxide. I group that together like that. Yeah. Okay, so marine pollution is, I think everyone's aware the danger and the issues about pollution. So pollution from ships, as mentioned just now, these are the groups of materials and things that's coming from the ship that is polluting. So we need to control this. And later we're going to talk about how we in the maritime community are doing to control this. So one of the control will be legislative regulations coming from international community, IMO, or from the state administration, from the national administration, which is our governments. And secondly, will be us as engineers and scientists and technologists. How can we control pollution from ships? So that's the thing that we will be talking later. So that's marine pollution. The second part will be invasion of alien species. Alien invasion, okay, it looks scary, and it is indeed scary because this is a classic example of the zebra mussel in the US, where in 1986, this mussel does not exist. There's very little in the lakes there. 1986. In 1990, it starts to have more. That's only 4 years. And not 4 years. Yeah, that's 4 years. And then within 10 years, it's become like that. And in 2013, it's like this. So it's all being transported by ships and boats coming from the lakes into the rivers and so on. And this is a dangerous species because it's not initially there in the other areas, but now it's being distributed all over. And it's clogged the water intake and so on. And people estimated the cost to be $1 to $5 billion. Yeah. So this is the issue, and that can happen in our country. In fact, it's happening in our country. I'm not sure about Indonesia, who's doing the studies on that. In Malaysia, we are doing studies. UMT has done, Universiti Malaysia Terengganu particularly, has done a lot of baseline studies, and we look at these issues of the invasion of species coming from somewhere else. It's not originally from Malaysia. So that's an issue, a big issue, because some of those alien species are actually dangerous to the local, either to the local like that one clogging the intake pipes and so on, or it is dangerous to the local biodiversity because these invasive species could be damaging to the original inhabitants of our ports, of our waters. Okay, number 3 will be carbon dioxide. Okay, and carbon dioxide we break into two. There will be two kind of menace coming from carbon dioxide. Okay, one will be causing global warming. This is well known, greenhouse effect. And the second one will be ocean acidification. So having too much carbon dioxide in the atmosphere is not going to only affect our global warming, and this should seem to be issues that is easily understood now because it's been very much in the picture. But ocean acidification is also an issue, And we can see ocean acidification, one of the costs of our coral, Indonesia, Malaysia, in our areas, tropical waters, we have a lot of coral previously. But one of the things that is affecting our coral health, is actually ocean acidification. In fact, there's a study here which measured the atmospheric CO, as atmospheric CO is going up in Hawaii, and the water. So the red line is the CO2 in the atmosphere, okay, which is this one, and the green line, the green line is the pH, Yeah, pH meaning the lower it is, the more acidic water is becoming. Yeah, so it's becoming more acidic. So we see that as the atmospheric CO increases, then the pH will also go down, and this is actually dissolved. Well, it is a measure of the dissolved CO, carbon dioxide that's dissolved in the water. So this is water CO, this is atmospheric CO2, sorry, carbon dioxide, atmospheric carbon dioxide, water carbon dioxide, and this is the pH. So it is going down, and that's affecting, like this, for example, they did in Florida, they studied how it's going like this. And if we do this in Malaysia or Indonesia, particularly in our coral triangle, Indonesia, Malaysia, Philippines coral triangle, we see the effect of this ocean acidification on the corals, the death of the coral, the biodiversity not only affect the coral themselves, okay, as an organism, but also affect shellfish, all the coral fish that lives in the coral habitat will also be affected. So that's a big issue from carbon dioxide itself. And of course, the other issue that is already well known, I don't need to explain a lot, will be global warming. Yeah, so global warming, that's an issue, and this seems to be the one that people talk more about, even in the COP26 and so on. People talk more towards global warming. Of course, because the effect is also big, yeah, but from the ocean point of view, we need to look into ocean acidification as well, because we are looking at ocean sustainability. Okay, global warming, people are aware about this. I'm not going to go stay in detail about global warming and so on. And this is a study in sea level rise in Malaysian Sea from 1993 to 2008 by UTM researchers. And they have been continuing to study, and even recently they published another one that I should have put that latest studies. And it seems that yes, sea level is rising, and it is proven. And of course, we know the effect of sea level rise. One of the effect will be some land areas will be inundated with seawater. That not only affect the area for housing and so on, where people inhabit, but it will also affect the fresh water availability. And because inundation of seawater will cause the water to become brackish and no longer available for drinking. So that's a big issue of sea level rise, and it is really an effect. So because of that, as I said, the two big COP, okay, conference parties have been happening throughout since Kyoto, but the two big ones are in Paris Agreement, 12 December 2015, which decided the target of not allowing it to go beyond 2 degrees, but targeting to get 1.5, yeah. And COP26 confirmed that, but looking into how we can do it better. And we are glad to see that the president of Indonesia himself attended the COP26 and gave good, we call it pledges on how to on what Indonesia wants to do in terms of we call it the NDCs, yeah, nationally determined contribution to the how we can contribute, yeah, to get this goal that we want to get the temperature to be not more than 1.5 degrees from pre-industrial level. Okay, so now if we go to carbon dioxide, we need to reduce carbon dioxide. How do we reduce carbon dioxide? We see that shipping is the most energy efficient mode of transportation already. If you see the trucks are giving 50 gram carbon dioxide per ton kilometer, the aircraft is the worst offender, 500 gram per ton kilometer. Whereas if compared to big ships, it's only 15 or 5. If a big tanker carrying lots of cargo, it carries the rate is only 5 grams of carbon dioxide per ton kilometer. So in a sense, we can say, oh, we are in the shipping industry, we don't have to do anything. We are already very, very clean and very efficient. Yeah, but the issue is our marine industry is developing, and the shipping industry, transportation industry is booming, is getting bigger and bigger. So even 5 grams later per ton kilometer, but we are the biggest carrier of all the international trade. So if you count by the kilometer and the ton, then we also become big. Yes, so also become big. So that's the problem. If we are not the biggest carrier, we don't carry too much, then it's okay. But because we in the marine transportation, we carry 90% of the world trade. So we carry a lot of tons and long distances. Because of that, although the rate is only 5 grams of carbon dioxide per ton kilometer, but it become big. Yeah. So that's why because of that we need to see our how we can help. This is you see how it's going up. Yeah, the what we call it fuel consumption. If we don't do anything, it's going up like this. I mean, going up almost exponentially. It's going up, and if we don't do anything about it, then it's going to shoot up because we expect the marine transport is also to grow. Okay, United Nations Development Program have predicted about how this trade will increase because of increase in trade. And UNCTAD trade will increase. Because of trade will increase, then we expect marine transportation will also increase in the future. So because of that, we need to do something about it. So what I've audited a few studies. They did first I'm PhD study, second PhD study, third and fourth was published last year. So already four International Maritime Organization GHG studies, and this was the amount. So the amount is 843 million tons of CO2, particularly in this is in international shipping is 143. Okay, the domestic one is something else. Okay, which is actually 2.7% out of the whole human beings emissions. Okay. So it is relatively small, but as I said, relatively small, but still 843 million tons is big. And if we don't do anything, it'll go beyond that. So because of that, there is also third IMO GHG study. Again, it says that this study business as usual scenarios project an increase by 50% to 250% in the period to 2050. So if we don't do anything, business as usual, then we will be in trouble. And in the fourth GHG study as well, the share of shipping emission in global anthropogenic emission has increased from 2.76% in 2012 to 2.89% in 2018. So we increase our share, and because of that, our amount is also now is beyond more than 1 million tons. Yeah, more than 1 million tons in 2018. Okay, so if we were to look at the graph, actually this is a projection, UNCTAD projection of world trade. Yeah, so this UNCTAD projection of world trade, if it is really going to go up like that, and we don't do anything about it, then our contribution to the global warming and finally, and also acidification and so on, will also increase. So we see later because of this, what we are doing. Yeah. So that's why we go to topic number 3, role of the maritime community, which is actually what we can do, and what has been done. Okay. So the first one, of course, is through regulations and conventions. Like, for example, we have MAPOL 7378. We know this MAPOL. They have 6 annexes. Annex 1, oil. Annex 2, chemical in bulk. Annex 3, chemicals in package form. Annex 4 sewage, Annex 5 garbage, and Annex 6 air emissions. So we see that all the issues that I've shown earlier about marine pollution as such is covered. Yeah, so it's covered there. These are the regulations, and including even the air emission, which is energy efficiency in this in the Annex 6. Yeah? So this Annex 6, yeah, Annex 6, this is ozone depleting substances, nitrogen dioxide, sulfur oxides, volatile organic compounds, incineration emission reception facilities, and finally in energy efficiency. So energy efficiency deal mainly with GHG, greenhouse gas emissions. So we have control mechanism regulations for NOx, nitrogen oxides, emissions, by having engines of various tiers. So by 2021, we are all the engine in certain areas, will be coming to tier 3. Okay, whereas the others are still on tier 2. So tier 2 already have certain standards of engines itself. These are engines, engine design. Engine manufacturers need to follow the standards. And by tier 3, they have also certain other standards, which I don't think we have time to go into detail. Okay, and then for SOx, sulfur emission, the main thing will be to control the amount of sulfur, the percentage, for example, where in California, for example, by 2012, they already want 0.1% allowed sulfur content in the fuel, whereas in the rest of the world, we are, since 2020, we have 0.5 control for sulfur content. And then, so that's about pollution, which is the first issue. The second issue would be ballast water, transfer of alien species, and we have now ballast water convention. It was already ratified and already enforced. Yeah. So by September 2017, and also the new one by for the renewal in 8 September 2019. So this one basically to control that, as you said just now, like I showed, the zebra mussel problem and so on. Okay, so you want to control this, then you have all kinds of ways of doing it. Yeah, we did a little study there in 2014. Okay, and we proposed to have a shipboard waste heat and additional system. Okay. Okay, for the greenhouse gas emission, this is the plan from IMO. Okay. They have what is called a greenhouse gas strategy towards 2050. And IMO has said to reduce carbon intensity by 40% within the next decade up to 2030, and 50% in total, 70% intensity up to 2050. So it was approved in 2018, and the reduction rates are related to the baseline in 2008. That's why you see we refer to 2008 as our baseline. So the plan is basically to put regulations such that the ship will have to follow, and with that they have to do, for example, EEDI. Maybe many of us have heard about this EEDI. Since January 2013, all new ships need to have a certain limit on EEDI, Energy Efficiency Return Index, and all ships need to have S.E.A, Ship Energy Efficiency Management Plan. EEDI is applied only on certain vessels, so a certain size above 400 ton, and this kinds of vessel. But SEMP is required for all ships. So SEMP is just a document such that the ship operators, maybe the master of the ship, need to identify how they are improving the energy efficiency of the ships. Okay, but this is the latest one. This one is has taken some by surprise. but it's already coming. So it's coming into force in 1st January 2023. So of course there is a leeway there until 2023, and we apply to all vessels because EEDI is for new vessel. Before this, only for new design. You need, when you design the ship, you must make sure that it is below the EEDI of certain value. But once you have EEXI, then we are looking at all ships must comply with EEXI regulations. The regulation is similar to EEDI. The formula is also almost, well, not exactly the same, similar to EEDI. So we have to calculate for every ship, we have to calculate the EEXI. And then if the attained EEXI cannot satisfy the required EEXI, the ship should implement countermeasures. So countermeasures is the one that is going to affect the operation of many ships and the economics of many ships. So this is the thing I mentioned earlier, that sustainability should not sacrifice one of the leg of the sustainability agenda. Cannot be. So we need to look also at the economics of implementing this. So I don't know about that in the Indonesian government. Particularly, we need to look into how this is going to be implemented and how it's going to affect our shipping companies, and how maybe as we as researchers, academics, and so on can also help. Okay, so all these regulations are actually to help to improve ship efficiency. The more efficient the ship is, the less carbon dioxide is going to make it simple, the less, so this regulation, if we can implement it properly, the ships are forced to not only being designed properly, that means that the ship designers and ship builders will make sure that the ships are designed properly, but also the ship operators will make sure that the ships are efficient. Okay, what are the ways that we can increase the efficiency of ships? This would be EEXI improvement measures. EEXI, that means the ships are already operating. If you have a problem about attaining the required EEXI, then you need to do all this. Oh, sorry, not all this. You need to do any one of these. Yeah, these are some options that we can do, and some of these are going to affect the economy of the operation of the ship. And so maybe we can do some research on how to actually do this without improve the efficiency, getting the required EEXI without actually heavily affecting on the economics operation of the ships. Okay, so the second thing that we can do is of course economy of size, and that's what's been happening in the container ship, business. So we see that in December 2008, okay, when IMO started the baseline, so there was only, this is the biggest ship at that time, it was the biggest, 14,000 TEU, okay, and by 2013 it goes to 18,000. By 2015 it goes to 19,000. In 2019, 23,756, and this is still not the biggest in the world. The biggest in the world now is 24,000 TEUs. HMN Galapagos, 400 meters. And this is in April 2020. I'm not sure this year, I have not checked, but this year. So she has 11 sister ships, currently the biggest container ship. So getting the ship bigger, of course, the economy of size, and then we can get more efficient. But of course, there are other ways of doing it. This is the design part. Maybe our designers, our researchers can help to design fuel-saving ships, okay, which is like reducing drag, improve conversion of fuel to power, improve conversion of power to thrust, extract as much as possible operational, and the operational approach should be more towards the ship operators. They operate by slowing down, and maybe by what we call as virtual arrival, and so on. So those things are the operation part. But we in the design and production industry, we need to design ships we can reduce drag or resistance, improve the engine itself. Okay, improve the engine maybe by using additives or designing proper engine, long stroke. All these are being done. Improve conversion of power to thrust. This is the propulsion system design, the propeller, for example, using PBCF here and so on. And then extract as much energy as possible. And finally, the use other energy sources. So using kites, yeah, various kind of solar, for example, so you use solar or wind as additional power to help reduce the fuel saving. So you save fuel. Not only you save, you bring economy to the ship, you also reduce the production of carbon dioxide. Just as a rough guide, 1 ton of fuel produce approximately 3 tons of carbon dioxide. Okay, so 1 ton of fuel produce 3 tons of carbon dioxide. So if we can reduce the fuel by 10 tons, that's we have already 30 tons of carbon dioxide saved. And maybe that's from one ship. So we have many ships we can save. So this is something that it is doable, something we call maybe partly we can call low-hanging fruit. And of course, we need researchers to look into this. Okay, finally, I have something as well. I think because we are talking about sustainability, so one of the things that in COP26 particularly are looking at renewable energy. And all countries, including Indonesia and Malaysia, have opted for, have proposed their intended declaration, they declare or contribution as the part will be the increasing of intake of renewable energy. So because of that, we need to look into ocean energy sources and in our country and help towards reducing this carbon dioxide. So Indonesia, for example, has pledged to reduce no more coal-fired station. So that's part of the pledge from Indonesia. Okay, no more coal-fired station. So how do you replace this? So you need to go to alternative energy. And we need to look into alternative energy. And we in the marine and ocean engineering, we look into how we can do that at sea. And of course, there are various issues around this. We can talk in other other platforms. Yeah? Yesterday there was a forum on ocean energy, and I was also involved led by Professor Mukhtasar. And I think the issues is we need to be realistic. That's most important. When we do things, we need to be realistic. We cannot overdo it and create unnecessary bitterness. People feel bitter about, for example, somebody will propose to put something and say ocean wave converter is the best. Finally, it didn't work, and people say they just everything is useless about ocean energy. So we have to be careful about that. So this is just a small project that we did in UTM. We try to just demonstrate a prototype device for ocean energy. We have 4 devices on one system here. So we have a wave point observer, we have OWC, or oscillating water column, and also we have solar panel, and at the same time we have a turbine, a 7-inch tidal turbine in the middle of the platform. So this is combined system. We call it combined ocean renewable energy system. So I think I go to the last part. Oh, I have 5 minutes. 4 minutes, sorry. So I have 4 minutes. I go to the last part. This is very quick. Okay. Preparing future ship designers and marine engineers. We can no longer keep designing things the same old way. Okay. So we think that we need to think differently. So when we teach our students now, our students need to have the sustainable agenda within whatever that they do. So when they design something and so on, they always need to think about that. So if previously, maybe when we ask the ship design, in the ship design class, we ask them to follow owner's requirements, for constraint of approval authorities, within the schedule and financial constraint and so on. and finally, the students will be looking at how to maximize, minimize the function and requirements and minimize cost to the clients. But now we need to do, to shift to maximizing the social benefit while minimizing the ecological impact. So that is something that we need to do. So instead of having only the traditional ship design criteria, we need to go on impact on people, impact on the planet itself. Okay, so that's why if we look at the some of student outcomes, yeah, this is in ABET need to have put a student outcome, and in they have the C. All students must be has an ability to design system component to meet design needs within realistic constraints such as economic, environmental, social, political, ethical, health, safety, maturity, and sustainability. So we need to have this in all our programs. Yeah, no matter is it either ocean, marine, or shipping, or even in other engineering. Yeah, other engineering as well. Okay, some other learning outcome from some other universities. This is also just pick up from the internet. They have something to do with environment. Okay, Newcastle. This is John Moore, including environmental risk. This is in Ireland. Okay, towards people and environment. This is Lithuania. Within yes, architectural solution in naval architectural solution in the societal and environmental context. This is in UTM. Okay, ability to identify the impact of naval architecture of engineering solution on sustainability and demonstrate the need for sustainable development. So, as concluding remarks. So the Earth is suffering from human actions. We know that. We don't have to elaborate a lot. Okay. Sustainable development principle and consistency need to be taken on board on all spheres of our activities. So including in our part of the world or our sphere of education and training. The strategy need to prevent mitigate three main problems: shipping activities, pollution, alien species transfer through ballast water, and global warming and acidification of the ocean. So the international community has done a lot. The military community, us, ship owners, designers, port operators, maritime educators, government agencies have big roles to play, and citizen education training need to shift to incorporate sustainability awareness and practice. So we come to 11:45 in Malaysia, 10:45 there, 45 minutes. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. You may contact me by email Yaakob@utm.my. Thank you.
Okay, thank you very much, Professor Yaakob. I would like to have participants, if you do have, I believe you do have very much question and remark, something like that. I think it's quite excellent presentation covering all matter regarding sustainability, efficiency, and something others. But the matter of commitment, I think that will be needed for elaboration. So I'll please participant to have question or might be comment or something like that. We will be having 15 minutes or so. Please. You may give raise your hand or you just speak directly to Professor Yaakob. Hello. You might need coffee or something. Okay, I would like to trigger one question to Professor Yaakob. I think the part of acidification that we are concerned, what we call it, not only regarding the fish or coral fish or something like that, but the spawning crown will be going further from the part of the from the beach and something like that, because due to the effect of the acidification. Do you have any recent research, this kind of thing regarding like tuna spawning ground, or might be blue fin tuna or yellowfin tuna that move further in terms of spawning ground?
I'm sorry for that question. That's beyond my knowledge, because I think I'm not sure. So far that I've looked into would be more towards how the carbonates from the seawater is affecting the formation of the coral carbonates, and also for the shells of shellfish and so on. Yeah, so like kupang, lokan, and so on. These are being affected by the acidification. But as far as fish is concerned, I'm not sure. I'm not in that field anyway. So maybe some other colleagues here can also share if they have some information on that.
Thank you. Bapak Ibu bisa aja pakai bahasa Indonesia, nanti saya translate. Oh, I believe that Professor Yaakob also familiar with Melayu, so
no problem.
All of you, why don't you have a question or comment in bahasa or bahasa Indonesia? It will be make you more pleasure.
Yeah, if kalau ada yang agak kurang selesa dengan bahasa Inggeris, boleh saja dengan bahasa Melayu.
Silahkan ibu-ibu, bapak-bapak, misters, if you do have any question or something, please raise your hand, or you just directly pick up a microphone and speak to Professor Yaakob.
Okay, kalau tak ada, tak apa.
Okay,
maybe it's clear.
One thing that I'm worrying is that when we are having meeting or COP26 or something, good thing is coming up, but the commitment is very low. Just like when I was attending I was a director for CTSFF up to 2019, but got a problem with my backbone, then I have to resign. But when I was attending the SDG meeting in Vienna, UN actually worried about implementation, rather than the just like COP26 commitment. But then after a year or so, we are having difficulties in commitment. So how is your thought or solution in that way, Professor Yaakob?
Okay, in fact, that's one of the worry as well in many platforms, many forums, because the intended the declaration on contribution, the national contribution, is actually not legally binding. Okay, you basically it's just your yes, that's what we are trying to do. It's not legally binding. So if you don't achieve so, nobody can punish you or anything. So that is true in a sense, but at least somebody, at least there is an intention. So kalau dalam Islam kan itu niat tu sudah berpahala. So dari segi itu berpahala tu kiranya niatnya udah. So the intention is to do good. But if you cannot do it due to some reason and so on, that's a second matter. It's a different matter. But the interesting thing is that we see in the NDC, the National Declared Contribution, a number of countries has increased their pledges. That means, like for example, Malaysia previously says only 35%, 35% reduction in intensity. Now Malaysia has increased to 45%. So at least now when they come back here in Malaysia, the ministers and so on, the people are looking at what do you mean by the 45% and how are you going to do it and so on. So we need to keep pressure on our government. I think if we believe strongly that we believe strongly that this 1.5 degrees, so we need to maintain the 1.5 degrees, not more than 1.5 degrees. And we have already declared, the countries already declared that they want to do that. Okay, so there will be two roles of us. Number one will be we contribute to it, yeah, by in our respective ways, like what I said just now. Maybe we do research, we do technology, innovation, and so on to improve that, improve energy efficiency of ships and so on. That's number one. Number two will be our own respective lives at home and so on. We try to reduce. And number three, I think it's also important. We become pressure group to the government and so on to make sure that the policymakers, to make sure that they honor whatever declaration that they make in the COP26. So that is also very.
Okay, Prof. I will be reading a question or two questions rather in the in the chat. One is from Mufti Polytechnic Batam.
Okay.
About offshore structure in the ASEAN region, which more than 20 years. Do you have any kind of solution or the way how to mitigate or whatever? Please answer. The second one was from Novan Arifidayat from ITS Surabaya. Kindly elaborate regarding the statement of fuel will produce 3 tons of CO2, part of your speech. So I think it's quite restate this kind of matter. There are two. Please answer the question, Professor Yaakob.
Okay. Number one is about the offshore structures. Offshore structures that has finished. It's not. We don't deal with 20 years. We deal with offshore structures which have ended their life or their useful life. The wells are dry and no more producing oil and gas economically. So these structures will be decommissioned. Will be decommissioned. That means they will be put out of use. To put these structures out of use, in fact, in Southeast Asia alone, there are more than 600 offshore structures of that sort. I mean, some are already 40 years old, some are 30 years old, some are 20 years old, but they are no longer producing. And according to UNCLOS, the United Nations Convention on Law of the Sea, it is compulsory for the state, the coastal state, to remove and make safe these structures, because these are supposed to be temporary structures, not fixed structures. When they put there, it's only to use to draw oil and gas. When they are finished, then something needs to be done to them. So there are 3 options now being considered and have been done. For example, in Malaysia, in Brunei, in Indonesia, I'm not too sure. Maybe there's 1 or 2. And mainly, there's a lot in the Gulf of Mexico. There are already 5,000 decommissioned structures. They have done a lot, and in the North Sea also they have done a number of them. So there are basically 3 main options. Number 1 is to cut them, remove them, bring back to shore, and recycle the steel and whatever material that can be recycled. That's number 1. Number 2 is to cut them and number 2 is to make use of them as reef, as artificial reef. I think the Department of Fisheries in Indonesia is looking to that as well, together with Pertamina or in the Indonesian oil companies. So this is called reef to reef. So you cut we call it cut the structures and leave it at sea so that it become reef for biodiversity to develop, and that become like artificial reef. And number 3 is to reuse the structure for some other use. For example, people are considering changing it into renewable energy, maybe put wind turbines on top there, maybe use it for aquaculture and some other purpose. So these are the 3 main ones. So of course there are sub to those, And I think this is also a good area of research. In fact, I'm involved in a research together with ITB, our groups in ITB, and it is a Southeast Asia collaboration on ITB, UTM, UTP, Mahidol University in Thailand, Vietnam Petroleum University, and a few other partners. So we are going to have a seminar next month. Okay, that's for that particular question. The second question, we have about 3 minutes. Okay, the second question is about, I'm not sure about this question. Elaborate more regarding the statement of one-time fuel produce 3 tons of carbon dioxide. Okay, if you, maybe it looks, it doesn't look what we call it logical, yeah, but it's actually combustion. Carbon dioxide is actually formed after the fuel is burned in oxygen. So all the chemistry and so on will finally come up with the molecule. There's no time to really explain. Well, that if you study that, basically the molecule, the weight of the molecules are heavier when it become to CO2. Okay, so to make things simple, so it become 3 tons, and that's quite easily proven. Okay, it's already proven. You can search easily on the internet about this. There are published because that's what the IMO use for the estimation of carbon dioxide emission from ships. They take how much fuel being used, multiplied by 3. Okay, but it's not exactly 3.0 something. It depends on the type of fuel. It could be diesel, it could be petrol, it could be natural gas, it could be whatever. So it has its own there. But it's roughly you can take as 3 tons. Okay, and then development of renewable energy for ships and so on. Maybe it's not. Various people are trying mainly using wind and solar, and solar energy. So far, solar energy is enough maybe to provide if it is small boats, yeah. But for big ship, maybe for ancillary services, maybe for more of supporting. Not that you cannot remove the generator from the ship, but still supporting. And also the wind are also being used only as also supplemental. So it's a wind assisted, not really fully wind energy like the sailing ship and so on. It's not like sailing ship. It is still using engines, but it is wind assisted. So by using wind, we can reduce the amount of energy or fuel, and with that, we can also save carbon dioxide. Okay, thank you. Thank you, Pak Widi.
Thank you very much, Professor Yaakob. I think exactly 11 o'clock. Please kindly give a big applause to Professor Yaakob as part of our. Thank you very much for your presentation as well as question and answer. So please give him a big applause.
Thank you very much.
Okay, so I would like to invite Professor Takeshi Shinoda from Kyushu University, please. Hello.
Hello. Can you hear my voice?
Are you? Yes.
It's okay.
Ready?
Okay.
Yeah. Professor Takeshi Shinoda will be giving a presentation in our future toward carbon neutral port. So, time is yours, and you will be having 45 minutes for presentation and 50 minutes for question and answer. Time is yours, Professor Takeshi.
Okay, thank you. Thank you for introducing. Okay, I will start with the. Is it okay to see that?
We haven't got your presentation material. No.
Okay. Okay, I will proceed. Okay, I'm Takeshi Shinoda from Kyushu Universities. I belong to the Department of Marine Systems. my title is Our Futures Toward Carbon Neutral World. It is a big title, and I worry had to.
Mungkin Pak Dedi bisa bantu bagian presentasi beliau.
Sorry?
Okay. Have you already presented your presentation in the share screen?
A share screen? Sorry, I have to change.
Post the share screen.
Okay. Change. Reverse. Is it okay?
Oh, not yet.
Not yet?
I don't.
Is it okay? Can you see?
Apakah ada yang sudah melihat? Have you seen? I didn't see that.
Oh. Can you see the screens and the PowerPoint exactly? No?
You might put in the chat your file, and then I'll be helping you. Or I don't know, but I think the organizing committee will be able to help you to have a share screen on your presentation.
Okay. I will do that. Sorry for bad management. And okay, I will share the screens by myself. And shares. Yeah.
Now it's okay.
Now it's okay.
Yes.
And then I click use. Is it okay to see that?
Yes.
Okay. I would like to start my presentations. I'm a Professor Takeshi Shinoda from Kyushu University. I belong to Department of Marine Systems, and my title is Our Futures Toward Carbon Neutral World. It is a big titles, and I worry about the explanation wells. And this is a trend of global warm temperature anomalies. And the National Center of Environmental Information, NOAA, opens the data set and provide global scale temperatures information. The global temperature increased around 2.08 degrees from 88. But the trend of the increase is 0.7 within 100 years, and 0.1 to 8 degrees within the 50 years, and 0.177 degrees 25 years. And the inclination is increased again and again. And this figure shows the trend of the CO2 emissions. The Joint Research Center, JRC, in the European Committee's reports the trend of CO2 emissions with atmospheric monitoring and inverse modeling for verification of greenhouse gases, GHG. Inventories in 2018. The figure shows observed the atmosphere's increase to carbon dioxide, CO2 since 1750s. Red dot indicate the ice cores measurements representing an average concentrations over 5 to 10 years. Block curves is from high precision measurement at the South Pole, which began in 1957 by the Charles David Keelings, who was the first discoverer of the CO2 curve. The important thing is the Earth energy imbalance. Many persons have negative opinions against the global warming by CO2 emissions. However, according to news sources from the NASA and the NOAA, the Earth energy imbalance has doubled since 2005. At the current rate of the heat uptake, greater changes in climate than era already occurring should be expected, new study finds. The researchers have found that the Earth's energy imbalance approximately doubled during only 40 years period from 2005 to 2090s. This figure shows mechanism of Earth energy imbalance by GHG CO2. And this is the sun. Sun energies reaches to the Earth as the solar energies, and the Earth radiate infrared rays, and the infrared rays are released to the space normally. But when the atmospheres with greenhouse gases, the atmospheres absorbed and radiate the infrared rays. The Earth system is gaining the energies, positive energy imbalance appears. It is causing the planet to heat up. And this slide shows mechanism of warm temperatures by CO2 emissions. CO2, it is a carbon dioxide gases, vibration by infrared rays of solar energies. The type 1 is symmetric stretching vibration, expanding and contractions. It is not for infrared exhibitions not effective, but the type 2s, it's anti-symmetric stretching vibrations. Infrared activations effective. Type 3s, this is the deformation vibrations. Infrared action is effective. Vibration storage the solar energies, and it is occurring warm temperatures. This is a mechanism of warm temperatures by CO2. This figure shows the key history and GHG reduction planning and actions. The United Nations Framework Convention on the Climate Exchange, which is called UNFCCC, is adopted in Rio de Janeiro in Brazil in 1992, around 30 years ago. The ultimate aim of the UNFCCC is preventing dangerous human interference with the climate systems. And this is shows histories. In 1992, the UN adopted UNFCCC. And in the 1997, COP3 is held in Kyoto, and the Kyoto Protocol is adopted. And in the 2015, COP21 held in Paris, and Paris Agreement is adopted. And in 2021, the last days, the US joined the Paris Agreement, and then the COP26 held in Glasgow in Scotland. The big difference of Kyoto Protocol and the Paris Agreement, the Kyoto Protocol is that top-down scheme by the developed countries. On the other side, the Paris Agreement is the bottom-up schemes, including the developing countries, and set the degrees, 2 degrees, set the target, the 2 degrees minus. And I also would like to explain about the Paris Agreement requirements. And Article 2.1, bracket A, the CO2 should be decreased, and then to achieve to the below 2 degrees above pre-industrial levels. And the background of the below 2 degrees, the scientific basis to require the target below 2 degrees is to prevent melting the ice sheet in Greenland. If it occurs, it causes the 7 meter sea level rises, and irreversible, not to get back to the originals, influences on the Earth. The carbon budget, which is the amount of the reducing the CO2, is total. It's a big numbers, 970 gigatons. We need to reduce that big CO2 tonnage near future. Additionally, I'd like to explain about the Paris Agreement requirements. The Paris Agreement requirement shows a roadmap of below 2 centigrades scheme, trajectories plans, the target toward 2030s, pick out the amount of CO2 emissions from each country and organization. Trajectory second, the target toward 2050s, rapid reductions of CO2 emission through utilization scientific methods and technologies. Trajectory third, target of the 2050 and earlier years within the centuries, CO2 zero emission in the world. The concept of the carbon neutral shows as effective method to reach the trajectories. It is to offset the CO2 emission in business activity, the industries, increasing all energy resources. This is a short history of the Japan's. The Japan also contributed toward carbon neutrals. 1997, the COP3 held in Kyoto, and the Kyoto Protocol was adopted. In 1998, Act on Promotion of Global Warming countermeasures. And Japan's amended that act the 7 times until now. And 2021, this year's new amendment of the act is executed in June to follow the Paris Agreement carbon neutral. Future of the new amendment of 2021, the first one is we need to achieve to carbon neutral society by 2050s. Second, we need to boost up introducing renewable energies. Third, we mandate the informing disclosures of GHG emissions, and also promote the DX, which is digital transformations. So we need to consider how to design new concept of carbon neutral port. This slide shows the research trial to reduce energy for CNPs in our laboratories. Our laboratory has been tackling the issues of reducing CO2 emissions. For example, the energy consumption analysis for hybrid type solar carriers and road guidance systems, fuel map for energy saving of solar carriers. It gets the patent properties. Alternating system for reducing energy of solar carriers and introducing a roof shade in the reefer container storage yards, and survey of the energy impact of a hydraulic power unit of the transport cranes, and the container handling simulations for considering planning the arrangement of the container terminals. And also big data analysis to visualize the situation of container terminals operations by use of TOS, which is container terminal operation system data. These trials would be useful visualization, and then the creating alternatives toward the CNPs. Here is practical examples for the solar carrier systems. We measure hybrid solar carriers performances. These are the measurement framework by the data loggers. Driver controls the machines, and we get the measurement items like output current of batteries, and lifting motor speed, and throttle opening angles, and hoist operating, engine speed, and state of charges, and fuel consumptions, and so on. It is too useful to understand the driver's operation when we get that measurement items. This is another framework using the videos and the analyzer ones. The compact video recorders, we had, it is easy to get the small size of the computer video recorders. And we introduced to install the devices to the every parts of the drivers and machinery parts. And the behavior of hybrid cell carriers to facilitate motions patterns there is recognized through the video analysis. This video shows fuel consumption maps. We got many data from the measurements of the hybrid cell carriers, and we demonstrate the historical movement of hybrid cell carriers shows the feature of the hybrid cell carrier motions. As you can see, the blue circle shows energy consumptions, and the bigger shows a large amount. It is made by a Java program by ourselves. And also we can indicate the battery discharge, battery charges, the fuel consumption, the brake weight and loads immediately, simultaneously. This is a battery usage maps, and the green circle shows battery charges, and orange circles shows battery usage. The bigger circle shows a large amount, and collected samples were 39 hours. When the drivers accelerations, the battery discharges happens to assist the accelerations. This figure shows the fuel map for energy saving of cell carriers. The fuel map is able to indicate fuel consumption from any arbitrary hybrid cell carrier position to all stack destinations in the Earth. The fuel map notifies the hybrid cell carriers drivers, and they can decide it to the optimal way to move. And it reaches to the energy consumption by the driver's management assistance. The other practical example is installations of roof shade in the reefer container storage yards. The objective is to keep the cooling conditions of the reefer container from the heat invasions from the high solar radiations. This is a roof shade. The sun shines and exposes much solar radiation to the containers, but the roof shade protect the radiations. This is actually photos in the installations of the roof shade. The roof shade made from the canvas like this. And when the transfer crane hears that the roof shade opens and get the containers from the top size. This slide shows experimentation size. We bring the containers, the reefer containers from Hong Kong, and we asked to the MOLs, malls in Hong Kong, and get negotiations and hire the 6 containers. And first, we experiment to catch the different containers performance. And then we installed the 3 containers in without roof shade and with roof shade, and compares of those and get the difference. We use this measurement experiment instruments and some couples, parameters, filmeters, anemometers, and use weather stations and get the informations to be effective to the leafer containers. This is the simulation for the solar effect, and as you can see, in the morning, the south side are exposed to the suns, and then the noon, the blue shade works well, and in the sunset, sorry, I would like to show again, but it's impossible to manage that. Okay. Next slide shows the effectivity of energy saving by installing a roof shade. And we compare the position of the different containers with the ratio of the power consumptions. The duration is the 10 a.m. to 11 a.m., the hot days. And this is the R1 shows the south side. C to the downside to the down tiers is the higher effectivities, and the north side is also higher effective, more than the south side. And these are the without roof shade, and we get these numbers. And also we get with roof shades, we get these numbers. The difference of these ratios is 12.76. So it means we get numbers as the power consumptions, the effect and the effectivities of the with roof shade. This is simulations for the heat prevention, heat penetrations. This is outside the airs. The heat penetrates to the walls, and heat inside of the leafer containers. And the key point is the thermal capacities of the walls. And another simulations results. Here is without roof shade, and here is with roof shades. Now, when the situation is without roof shade, the top containers is hotter than the without roof shade. You can compare the hotter one is red colors, and then you can compare the situation visually. And this figure shows the temperatures of the with and without roof shades. When the situation is without roof shades, the temperatures are the highest like this. And the straight line shows the simulation results, and the dot line shows the experimentations. And the two results fitted wells. And we can compare the difference of the without roof shade and with roof shades. In the case of the with roof shades, the temperature highest temperature is very low, and it means the roof shade is effective than the without roof shade. Another practical examples, the container operation simulations. We made simulation models by the softwares mode, and compare the arrangement between the parallel arrangement, storage arrangement, and the vertical storage arrangement by the simulations. This is one example of the simulation results, the AGV travel distances. This figure shows average travel distance by AGVs. The horizontal axis shows the number of the AGVs, and vertical axis shows the AGV moving distance. Vertical arrangement has advantage to travel distance by AGV more than parallel arrangement. It means vertical arrangement has lower energy consumptions. However, vertical arrangement should be considered that it considers the container is carried to storage area by stacker cranes. That's stacker cranes. Here's containers from the ships, and stacker crane gets the containers and bring to the chassis. And the stacker cranes works too much. And it means we need to travel distance and another energy consumption by stacker cranes should be considered. This slide shows the another aspect from the viewpoint of service times. Vertical arrangement also has the advantages. Sorry, cannot see. Okay. And another practical example of big data analysis for container terminals. Here is a study allocations. We always use this Hakata Island City container terminals, HICCTs. And this is the HICCT layouts. And it has the two buses. The bus's length is 680 meters, and depth is 40s and 50s. And the storage size, it has the capacity of capacity is 223, around 24,000 TEUs. And the yards have the 5 gantry cranes, and that width is 18 containers rows-wise, and the transfer crane, they has 21 units. It has a special made and 8 container rows-wise, and also full electric drives. This slide shows the TOS, Terminal Operation Systems data of transfer crane with the timestamps. Data compose transfer crane movement, address, and its time, kind of the positions, and container ID numbers. And it is a unique numbers in the world, and the chassis ID and so on. Data set is 1 year from August 1st to 2017 to July 31st, 2018. It is just 1 year. And this slide shows one example, analyzed the storage areas usage from the overall movements of containers. We divided three mainly: inland, outland, and internals. The internals composed of the import, deliveries, and the rehandlings. Outland may include export, receive, shift operations, shift out, rehandling by shift, and shift-ins. And internal means that drivers manipulate the containers by himself to be effective, to make effective arrangement. And as you can see, all storage areas almost same numbers. It means it's small deviations, but the other side, from the viewpoint of the rehandlings, it has the 40, 47, and we counted the totals. And the rehandling is the 38.3% of the all movements, to very big, and we surprised that analyzing it. The time is coming, so we need to speed up. This is the another examples of the data analysis for movement of the transfer cranes. The movement data are sorted by the highest to lowest. Here is a breakpoint between the weekdays and the Sunday and holidays. The workers work well in the weekdays. On the other hand, they take the Sunday and the holidays. So it means not the 24 hours terminals. The maximum movement is the 5,235, and the minimum one, the 1,979 in weekdays. It is the peak and bottoms, and 26 times. It means it's difficult how to design the container terminals. Okay. And another aspect of the transfer crane, the transfer cranes moving from the submarines and the works. It's a quite frequent trees. It means the energy needed to the move on to the another range. Here is the country crane size, and we can calculate the average cycle time and the number of the works of the country cranes. And we can summarize the energy consumption by big data analysis. And we get that the numbers, the CO2 emission of the terminals, that has the two type of the control terminals, CASI and HICCTs. The total is 4,964 tons of CO2 emission per year. And also, soil carrier system has the 6.1 to 3 kilogram of the CO2 per unit, and 5.479 kilograms of CO2 per unit is for the transfer crane system. When we compare the two systems, the transfer crane system would have the advantage a little bit. We need to make alternative scenarios towards CNPs. There are some alternative scenarios towards carbon neutral ports. The important keywords is visualizations of actual situations. It includes maintenance of data acquisitions, the establishment of monitoring systems. The other keyword is model-based designs. It's necessary to establish a simulation model toward design by analysis. It's also important keywords. And the another important keyword is the policy making. How to make incentive to reduce CO2 emissions, replacement of facilities, finance, technology support.
Professor Takeshi, your time is up.
Okay, almost finished. Yeah. And almost finished. Okay, it is okay. My presentations. Okay. Thank you.
Okay, thank you very much, Professor Takeshi.
Yes.
For having excellent presentation. Yeah. I know that a lot of elaboration and work. So hopefully that there will be question and comment from participants. I'll give you the time, please. Bapak Ibu juga bisa naruh di share di chat, nanti saya sampaikan dalam bahasa Inggris ke beliau. Or you may directly, I don't know the way, but silakan. Professor Shinoda,
yes.
Triggering a question.
Yeah.
By having your theme, your title of research, what will be the probability of success in Japan by 2050? You mentioned that by 2050, hopefully that will be what we call it with toward carbon neutral port. Japan, right?
Yes.
So what will be the probability of success, do you think?
Yeah. Almost.
So you are having a big picture to have success up to 2050?
Yeah. Yes, from the faculty, the research collaboration with the content terminals, our laboratories, proceed to reduce that CO2 emissions.
Okay, but when you take a look the situation in other big ports, such as China, Indonesia, so you might be a bit pessimistic in terms of this kind of thing, though. With people population big, you know.
Yeah. It is related with the populations because for example, our Japanese is the import companies.
Yes.
And the vacant containers gathers various. And then we export the vacant container to the outside from our countries. And it means we are dependent. We are not independent of the effect of the containerizations of the global economic situations. So Indonesia's also in the futures, the many import countries and Indonesia do not avoid that situation of the CO2 inclinations. And in China's already the big import and big export country, and then the much CO2 emissions that happens and increasing every year. But that the countries not focusing now to reduce the CO2 emissions. Sorry, this is a political comment. That the countries.
Yeah, you might also face like India, you know.
Yeah, okay. Decrease the CO2 emissions. But fortunately, the good news, the big game change happened. As you know, the use electric powers. So for example, the electric vehicles, using the electric vehicles, using renewable energies, it becomes a big game changes.
Okay.
In the world.
Silahkan Bapak Ibu, please participant to have question or comment to Professor Takeshi. We still have 10 minutes though. Saya sedang moderator. Ada pertanyaan. Gimana?
Some people that raise a hand.
Okay, I didn't see that. If there is somebody raise the hand, just open up the speaker and have a talk, because I didn't see the raise hand or something. See, Professor Takeshi?
Yes.
So you just mentioned I didn't see that. Let's see. Can you mention the person name?
Hello.
Ya, silakan.
Okay, my name is.
Ya, silakan langsung aja.
My name is Alifa. I'm from ITS Surabaya. I'm sorry, maybe my question is out of the topic. And my question is, to reduce carbon emissions, until now there is still a dilemma regarding the change of fuel oil to renewable energy. This is because the costs are very large. discusses the renewable energy projects that we have created to receive least attention from the government and society. So how to overcome this situation? Thank you.
Yeah. Our country takes many options, including the renewable energies. But I think as you know, the renewable energy is dependent on the weathers. For example, sunshine, the strong wind, and so on. But we keep the basic powers. Basic power is important. Basic powers and additional powers using the renewable energies. So it means that basic power is important. So in the Indonesia, you are the very clever countries. You introduce the earth energies from the underground and use the hotter heat areas and make the boiling waters and use it combine the generators and get the energies. And the Indonesia has the clevers to introduce that as the renewable energies. And if you keep the basic energies with the renewable energies, it would be important. Don't forget about that, the basic energies. Not fully changes to the renewable energies. Basic energy is important and reduce the CO2 emissions from the basic energies.
Okay, thank you. One more question from Raskianti. Ms. Raskianti is a student in ITS, asking about the, what do you call it? We know there are 78 countries of 2013 contribute 72% CO emission. How to serve? Oh, sorry. This is the second one. How is your opinion carbon trading in reducing carbon? This is from Ms. Raskianti. The other one will be from Mr. Dr. Handri Chandra regarding there are 78 countries of 2013 contribute of 72% of CO. How to solve the root of those problems? So there are two more questions, please.
It's a difficult question, but I think you do not forget that this era is big game changes eras. The energy resources will be changes to the shifted to the electric powers and green renewable energies also. And I think you don't know well the new energy resources. Energies, of course, you know the energies, but also the ammonia and hydrogen is the another energy resources to reduce the CO2 emissions. And this is an important keyword, and the big era is now coming, and everyone have the chance to grow up the resources, your countries, our countries, and so on. The big game changes happened. It is suitable the answers to the questions, but I would like to impress that the keywords, game changes.
Okay, so basically a big policy will be changing, so a lot of matters will be follow up the changing of the policy.
Yeah.
Okay, so
we have
there is no exactly answering the two questions, but I think you have a big picture.
Yes, big pictures and big Mars.
Silakan, we still have 3 minutes, Bapak Ibu. We still have 3 minutes. Tapi saya mohon ditulis di di chat aja, karena tadi waktu memberi sinyal nggak kelihatan. Silakan kalau masih ada, write down in the chat messages.
Yeah, to the young person, I'm an old man, around 60 years old persons. But
there is no such old, Mr. Takeshi, you know?
From me.
Keep working and keep working.
Yeah. I'm now 60 years old persons. But in futures, the climate crisis would come when we export the CO2 emissions. And I cannot say about the problems when the Greenland ice, the meltdowns, the 7 meters higher, the sea level is higher, and where we live, where we keep the living spaces. I'm an old person. In future, I will just dying, but the young persons need to consider what will be happen in the futures. So this CO2 carbon neutral will be important. Don't forget about that.
But I think you still having good time in Japan rather than in Kiribati in the Pacific, you know. They're worrying the way how they live because seawater rise is almost getting to everywhere. So at least Japan is much better than the Pacific. So we still have 1 minute. We would like to congratulate to Mr. Takeshi for having excellent presentation. So hoping that a big applause for Mr. Takeshi Shinoda. So thank you very much. There is an instruction from Andi Chandra. Oh no, request, yeah, taking picture from Professor Widi and Professor Shinoda. I don't know how to do that, but please.
Okay, I can do that.
Okay. So,
I do my myself.
Okay. Pak Andy, please do. And hopefully that please having a big applause for Professor Shinoda.
Thank you. Terima kasih. Thank you.
Arigato gozaimasu, ya.
Yes.
So waktunya sudah habis. Saya sampaikan kembali ke panitia. So I will put the time back to the organizing committee for having next agenda for break or whatever. So silakan Pak Dendi dan kawan-kawan yang akan memutuskan adjourning the session. Waktu sudah habis. Silakan, kami persilahkan. Saya nggak tahu foto tentang foto Pak Dendi. Tapi mungkin bisa ya, saya nggak tahu. Halo, panitia.
Thank you, Prof. Widi Agus Pratikto, Ph.D., Prof. Omar bin Yaakob, Ph.D. from University Teknologi Malaysia, and Prof. Takeshi Shinoda, Ph.D. from Kyushu University-Japan. We will take a break for an hour. For each day, we will choose the best participant. They will receive souvenir from ISOCEEN 2021. So prepare your question to discuss regarding ocean coastal engineering innovation with our speakers. See you at 1 p.m.
Bisa ngambil foto, Mas? Oke, whatever.
We can take a picture. To all participants and to turn on the camera for documentation.
Mohon videonya dibuka karena panitia mau mengambil foto. Silakan.
I remind again to all participants to turn on the camera for documentation.
Professor Shinoda, can you put on the video? Sudah live, mungkin sudah live.
Okay, I will count in for the first page. 3, 2, 1. Okay, for the second. 3, 2, 1. Thank you. All participants can turn off their camera again, and we will take a break for an hour. Thank you.
Okay, have a good day, Mr. Shinoda and Professor Yaakob.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi Sepuluh Nopember, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSIS, Vocation, Creatis, Martech, Electrics, Plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes. The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi Sepuluh Nopember, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSIS, Vocation, Creatis, Martech, Electics, Plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes. The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi Sepuluh Nopember, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including scientists, Insist. Vocation. Creatis. More tech. Electrics. Shift plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes.
Years, we have continued to grow and build maritime community empowerment in Asia Pacific. As a quality and customer-oriented institution, we have been awarded national and international accreditation in each department respectively, which proves that Martech ITS Surabaya is an excellent place to study marine technology and engineering. Martech ITS Surabaya has many accomplished professors and doctors whose numbers will continue to rise along with our commitment to produce the best engineers who are completely ready to deal with the business and industry in the maritime field. Martech ITS Surabaya provides an outstanding educational environment and superb facilities for students in order to improve themselves better. Hence, we are trusted to be an educational institution to help on building hard and soft skills of the students. Martech ITS has a strong focus on teaching, scientific research, and community service on marine technology and engineering's development, utilization, and transformation. Together, we build and keep moral ethic values on the whole aspects of the educational process to create sustainable and eco-friendly empowerment of marine-based community in the global region. Martech ITS Surabaya continuously improves to learn in order to be ready for facing future challenges. Thus, we continue to develop learning and delivery methods which could be accessed by people. Martech ITS Surabaya always encourages students in academics to obtain benefits and take part of great opportunities provided by many international programs. Martech ITS Surabaya always strives to launch innovations in the development of technology and engineering in the maritime field and foster maritime insights and culture as well. From the various efforts accomplished by Martech ITS Surabaya, this faculty has achieved many prestigious awards, which certainly become a motivation and benchmark for students as well as academics to perform better and continue to compete in the maritime field. Established for 60 years, Martech ITS Surabaya has cooperated with companies and institutions engaged in the maritime sector. We are proud to have so many inspirational alumni who have gone and achieved significant success since graduating from Martech ITS, whose contributions to the maritime industry are not only nationwide but also worldwide. And we believe the future generations can prove to be even better. So, come and join us on a voyage across the sea for the next 60 years with Marine Technology, Institut Teknologi Sepuluh Nopember, Surabaya.
Come and join us.
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 See you in the future. See you in the future.
Okay. Mute lagi dulu aja.
Studi Teknik Kelautan ITK dibuka berdasarkan Menteri Riset, Teknologi, dan Pendidikan Tinggi nomor 338/KPT/1/2017.
Teknik Kelautan Ocean Engineering adalah program studi yang menekankan pada kemampuan dalam merancang, mengembangkan, dan menganalisis struktur bangunan lepas pantai dan sekilas ilmu tentang bangunan pantai. Struktur lepas pantai yang dibahas menekankan kepada bangunan apung, subsea system untuk menunjang deepwater teknologi, dan juga survei dan inspeksi yang berhubungan dengan industri di bidang teknik kelautan. Sehingga output yang dihasilkan berupa tenaga di bidang teknik yang unggul, kompetitif dalam bersaing, dan memiliki etos kerja yang baik. Setiap lulusan dari program studi teknik lautan ITK akan dibekali pemahaman terkait dengan ilmu dasar-dasar teknik, ilmu dasar teknik lautan, desain bangunan laut, pantai dan lepas pantai, penguasaan perangkat lunak, dan pemahaman terhadap aturan yang digunakan untuk desain bangunan laut, pantai, dan lepas pantai.
Bagi kalian yang ingin melanjutkan pendidikan kalian ke jenjang yang lebih tinggi seperti perkuliahan, saya saranin sih masuk teknik kelautan. Apalagi bagi kalian yang memiliki passion lebih terhadap arsitektur, desain, atau perencanaan yang anti mainstream lah. Nah, menurut saya teknik kelautan adalah wadah yang sangat cocok bagi kalian. Karena di teknik kelautan kita membangun platform di lepas pantai.
Menariknya di teknik kelautan, di Indonesia sendiri program studi ini masih sangat sedikit serta lulusannya juga tergolong masih sedikit. Sementara di Indonesia adalah negara maritim dan akan menjadi poros maritim dunia. Jadi lulusan-lulusan terbaik teknik kelautan akan sangat dibutuhkan oleh negara untuk mewujudkan Indonesia sebagai poros maritim dunia.
Karena di Indonesia itu kampus-kampus yang memiliki program studi ini masih jarang ditemukan.
Penerimaan mahasiswa teknik kelautan ITK dimulai pada tahun 2018. Kegiatan perkuliahan, mahasiswa teknik kelautan ITK juga berperan aktif di kegiatan non-akademik, seperti himpunan mahasiswa, keluarga mahasiswa, dan unit kegiatan mahasiswa.
Teknik Kelautan Institut Teknologi Kalimantan saat ini sudah memiliki himpunan yang resmi berdiri pada bulan Maret tahun 2020.
Tidak hanya itu, mahasiswa teknik kelautan ITK juga dapat mengembangkan diri melalui pelatihan dan lomba. We are tied to the ocean. Moto ini membersamai teknik lautan untuk menjadi program studi yang memiliki keunggulan untuk pengembangan sumber daya dan potensi daerah dalam pembangunan Kalimantan dan Indonesia dalam bidang teknik lautan pada tahun 2025.
Visi kami adalah menjadi program studi yang memiliki keunggulan untuk pengembangan sumber daya dan potensi daerah dalam pembangunan Kalimantan dan Indonesia dalam bidang teknik lautan pada tahun 2025. Misi-misi kami yaitu melaksanakan program pendidikan yang berorientasi pada kebutuhan dan kemajuan ilmu pengetahuan disiplin ilmu rekayasa kelautan untuk menghasilkan lulusan-lulusan yang unggul, menyelenggarakan penelitian untuk mengembangkan ilmu pengetahuan dan teknologi di bidang teknik lautan, dalam pengembangan sumber daya dan potensi daerah Kalimantan, serta memanfaatkan hasil penelitian dalam kegiatan pengabdian kepada masyarakat. Mengembangkan kerjasama dengan instansi nasional maupun internasional yang berbasis teknologi kelautan, melaksanakan manajemen program studi yang kredibel, transparan, akuntabel, bertanggung jawab, dan adil. Tujuan program studi teknik kelautan antara lain memiliki lulusan unggul yang profesional, berakhlak, bermoral, beretika, berkompeten, dan mampu bersaing dalam disiplin ilmu rekayasa kelautan. Menghasilkan penelitian yang inovatif dan bermanfaat dengan riset dan teknologi di bidang teknik kelautan yang berkualitas untuk mendukung pengembangan sumber daya dan potensi Kalimantan. Memberikan kontribusi kepada masyarakat dalam memecahkan permasalahan di bidang rekayasa kelautan terkait dengan pemberdayaan potensi daerah Kalimantan, menjalin kerjasama dengan akademisi, stakeholders, instansi nasional maupun internasional yang berbasis teknologi kelautan.
Dalam berkuliah di program studi teknik kelautan ITK, teman-teman nantinya tidak hanya belajar mengenai hal-hal akademik, namun juga belajar tentang non-akademik, sehingga yang didapatkan pastinya selain hard skill, yaitu mata kuliah di program studi teknik kelautan, juga ada soft skill. Nah, soft skill ini bisa berupa dari lomba-lomba, kemudian pelatihan, dan juga kegiatan ormawa. Di ITK ada berbagai macam organisasi mahasiswa yang dapat diikuti, mulai dari himpunan mahasiswa di tingkat prodi, kemudian keluarga mahasiswa di tingkat institut, kemudian DPM juga, dan juga UKM atau unit kegiatan mahasiswa. Melihat tantangan industri atau kegiatan pasca kampus saat ini, tentunya para mahasiswa harus benar-benar menyiapkan diri mereka. Dengan potensi yang sudah dimiliki saat ini, mahasiswa juga dapat mengembangkan diri secara akademik. Pemahaman terhadap materi kuliah, baik itu di dalam kelas maupun di luar kelas, sangat dibutuhkan. Oleh karena itu, para dosen juga sangat membuka kesempatan untuk para mahasiswa agar dapat berdiskusi di luar dari jam perkuliahan. Selain itu, untuk non-akademik, termasuk skill, kita juga membekali mahasiswa dengan cara berkomunikasi atau menyampaikan pendapat, lalu presentasi, teamwork, dan juga leadership.
Selain prestasi mahasiswa, para pengajar di teknik lautan ITK juga memiliki berbagai macam kompetensi terkait bidang teknik lautan. Sampai saat ini sudah ada kegiatan bersama untuk mendukung perkembangan ilmu pengetahuan dan teknologi di sektor industri maupun pemerintahan. Informasi lanjut mengenai teknik lautan ITK dapat dilihat di laman akun Instagram kami di bawah ini @oe.itk dan laman akun website kami di www.oe.itk.ac.id dan laman akun YouTube kami di OE Official.
To all participants and audience, we are back to the 9th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, or ISOCEEN 2021. We will go to the second session, and for this session, the moderator will be Prof. Daniel M. Rosyid, Ph.D. For Prof. Daniel M. Rosyid, Ph.D., time and place is yours. Nah, apanya? Dia belum ngomong, saya nggak dengar suara dia tuh. Udah mas, udah mas. Tapi saya nggak dengar suaranya MC.
Ya, dari MC sudah bisa dimulai ke Prof.
Oh gitu?
Iya.
Tapi ini saya enggak, ya. 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 Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh. A very good afternoon, ladies and gentlemen. My name is Daniel Rosyid. I'm happy to be chairing this afternoon session of this ISOCEEN 2021. We are going to have two keynote speakers. The first one is Dr. Shahrin Osman. He is from the DNV Maritime Region, Southeast Asia, Pacific, and India. His presentation is titled Collaboration as the Fuel for Shipping Decarbonization. The second speaker is Mr. Iqbal Fikri. Mr. Iqbal Fikri is presently the production director of PT PAL Indonesia. His title of presentation would be Opportunities for Collaboration in Indonesia Blue Economy, Perspective of the Maritime Industry. Ladies and gentlemen, audiences, respected keynote speakers, I will let Dr. Shahrin Osman to present his views and experiences as the director of the DNV Maritime Region, Southeast Asia Pacific, and India. The time for Dr. Shahrin Osman will be 45 minutes of presentation and followed by 15 minutes of question and answers. Please, Dr. Shahrin Osman.
Okay, so can you hear me now?
Shahrin, please. You may start. Yeah, okay.
Okay, let me show my screen.
Good, yeah, okay.
Okay, sorry.
Okay, no problem.
Okay, I hope you see this screen. Okay, Assalamualaikum. Good afternoon, good morning to everyone. Thank you for inviting me to share my industry perspective on the topic of important topic of decarbonization as well as on collaboration. So for my 45 minutes or so presentation, I hope to cover these three areas. First, to give the perspective of the background on carbon emission in maritime sector. There's been a lot of development within this area, so it's really important for us to understand what are the most recent drivers behind that. And then I will share several case studies on collaboration within decarbonization within the area of alternative fuel. And then especially for the researchers and the university's participants is to discuss on also it's possible to collaborate using simulation platform. So I hope to cover these three areas within my next 30-40 minutes or so. But prior to that, I'd like to just give a bit of background of DNV so you understand my perspective. I think we are, obviously it's been around within the maritime or the shipping side for more than 150 years. Our core business indeed is ships classification. But maybe it's also interesting as we talk about sustainability and shipping decarbonization, that within DNV, we have in fact a larger unit than maritime. We call it the energy systems. So this is really looking at things that are continue to evolve, such as the renewables, the offshore wind, solar, and the smart grid, and the importance of linking up between maritime and this shore-based industry, because maritime, in terms of alternative fuel, it cannot work on its own. And we do have other business areas such as our software and digital, as well as certification. And what is also interesting to share is then that within DNV, on annual basis, we spend about 5% of our revenue annually on R&D. And this involves maybe close to 200 million euros, every year that we spend on R&D. And for this R&D, we do a lot of publication. And this publication has been widely cited in a lot of studies and reference. So the next slide, I will actually share with you some of our publication. And from this publication, then that sharing some of our forecasts, looking at the future of energy transition. So here, a list of the publication. For example, our energy transition outlook now is in our 5th year, that we look at what would be the energy transition towards, for example, renewables or clean energy in the next 3 decades. And then we look at what does it mean for the ports, as well as what does it mean for maritime and other industries. And also looking at what are the technologies that will be considered to be critical for us towards this energy transition. And the majority of some of this technology will really be important when we want to look at how quickly we can go to have a cleaner shipping industry in the next 3 decades. So it's all available, this report online in our website. So I would encourage, I think for those of you interested to look at it. And one of the key aspects of this energy transition and the forecast that we see is then that in the next 30 years, actually we expect the shipping trade to grow. And we work out based on different scenarios. As you know, it's difficult to work out the GDP. So it can grow between 25% to 250%. And indeed, there's a lot of uncertainty, I think, when we look at the future. But what is certain is then that we know that the gas segment will continue to grow. The world will be moving away from dirty fuel such as coal or oil, moving towards gas. And we know then that industrialization and consumerism will continue in other parts of the world. So the container trade will grow because this is where we carry a lot of consumer goods. And we know then that the global demand for coal and oil will peak, and then when they peak, of course, then the trade, for them to be used as fossil fuel will reach a peak within the next 10 years. So this is looking at the bigger picture with regards to where we see the trade growth. And on that note, when we look at decarbonization, there is one global organization that sets the regulation that everyone within the shipping industry globally needs to comply, and this is IMO. And IMO has set a very ambitious target. We call it the IMO 2050 target, that it wants by 2050, shipping needs to decarbonize by 50% of the greenhouse gas emission, because that is in terms of the 30 years. But in the short term, shipping is expected to reduce the carbon intensity by 40% within this decade itself, and that expected to increase to 70% within the next 3 decades. So you imagine then that whatever we are doing right now, and the assets that we have right now normally last for 20 to 25 years, this expected to change within the next 10 years with regards to the short-term measures, and then within the longer term, in the next 30 years, significant reduction expected from shipping. So we need to react as an industry fast, because this is coming, and this is not a proposal, but it has been accepted by all the member countries. But beyond the regulatory requirement, the customers of shipping, that means the charterers and cargo owners, they themselves expected the maritime industry to be green. So they, as a charter or cargo owner, they have developed a framework to monitor the assets that they use to transport their cargo. Can be coal, can be, let's say, iron ore, can be oil, or can be other consumer goods, like this gas. They expect the assets that they charter in to do the transportation to reduce its emission using the IMO framework, then to look at how much they consume based on the cargo that they travel. So this is something that, as an asset owner, if you want to continue to serve, you have to reflect a lot more efficient in terms of your operation and to reduce your emission. But beyond that, beyond that is then that the end consumers, the NGOs, they are also pushing for maritime to reduce. The next slide, for example, will show big players like Shell. On their own, they will expect, their suppliers, the shipping companies to reduce. And one of the key reasons is because the end consumer, and here a court in The Hague, putting it a requirement that Shell has to reduce its own emission by 45% over the next 10 years. So this is huge. And what does it mean, right? That means that Shell's own operation for the, oil exploration, EPC needs to reduce, but also the emission of its suppliers. And within our maritime industry, it means all the shipping companies are expected to reduce its emission from the operation, whatever they do right now. Beyond that, we also have seen other NGOs, pushing the largest retailers like Walmart, Amazon, or Target, that within the next 10 to 20 years, that they have to move their cargo on non-fossil fuel ships. So you imagine whatever we do right now, the pressure is not just from IMO regulation, the pressure is from the direct customer of shipping company, but also end consumers expecting for shipping to get its act together and reduce the emission. And we know then that shipping is an asset-heavy industry. What does it mean? That means then that you require significant amount of finance for you to buy the asset. Each ship can cost, those deep sea vessels can cost between 40 million to 200 million, right? So you need a lot of finance to operate as a business entity to get new ships. And within the finance side, there is now also various regime scheme in place that before they release the money, they want to assess how efficient is your ship, how much emission it will expect to reduce. And the expectation is then that whatever financing is being done right now, that it has to reduce the shipping emission by 50% is IMO target by 2050. So you can see then that as a ship owner within the shipping industry, you cannot run away from it. The regulation forces you to do it. Your customers forcing you to do it because they are also being forced either by the courts or by the end consumer, wanting shipping to decarbonize. And if you want to invest, running your business, you need the finance. And finance also set the same expectation that, that you have to reduce significantly within the next 3 decades. So what does it mean then for the shipping side? What do we need to do for us to reduce our emission? The next few slides, then I will share in terms of what is a pathway. It's going to be a complex in terms of the way forward. So you need to have a clear pathway in terms of how to move towards net zero carbon shipping. And when we look at shipping decarbonization, Normally, there are 4 different areas that we can look at. One is to improve your operations, to optimizing your logistics and the use of digital technologies. So there's a lot of connectivity now has been put in place on the asset, just like what we see in the aviation sector, that at any one point of time, for example, Rolls-Royce control center on land can have a review of the performance of all the aircraft that's running on Rolls-Royce engine, right, that's flying. Similarly, for shipping, moving into that direction to have the connectivity of whatever happening on board that you are able to monitor from shore. That allows you then also to look at your speed optimization, because speed has a very close relationship in terms of your emission, and how, as a logistics, you utilize your vessel well, looking at an optimal vessel size as well as looking at the alternative route. So there's one aspect about the operations, the logistics, as well as the use of digital technology. But on the design side, there's the area about hydrodynamics. That means you reduce as much as possible the friction, the resistance. So through hull coating, optimization, or air lubrication. So that is looking at in terms of the resistance for the ship, right? But also to look at the operating aspect of the machinery, to look at how you can improve the machinery, activities, using battery as a hybrid technology, so then that you can reduce, to derate your engine to lower, so then that you don't consume as much, or use waste heat recovery. So all of these areas you can see you can reduce between 5% to more than 20% in terms of reduction. But that itself will not be enough. I've mentioned earlier, there's expectation from IMO for shipping to reduce by 50% within the next 3 decades. So this means then that shipping needs to start to explore alternative fuel. And what has been happening within that sector is then that LNG seems to be dominating now with regards to alternative fuel, because LNG has a much higher energy density. Also on electrification, to put, for example, energy storage systems such as batteries on board. But batteries, we know then that we always have a concern with regards to the distance to cover. So batteries will be pervasive within the hovercraft, the short sea segment, but not within the deep sea. Biofuel is also being considered, and in fact has been pilot. But biofuel, we know the challenge about getting the feedstock, that we are also competing with other use of those feedstock like wheat or grain. But also biofuel will be competing with other industries such as aviation. So probably aviation would have a better capacity actually to pay for biofuel, which is difficult for maritime sector to compete on price. Or looking at hydrogen-based fuel. Hydrogen by itself has now been applied for short sea ferries. But there's a lot of areas looking at on other hydrogen-based fuels such as green ammonia. I'll try to cover more of it. And then going back in terms of the need for shipping to decarbonize significantly within the next few decades, this being presented in our report of our maritime forecast towards 2050. So you can see then that in terms of where we are now, let's say in 2020, that within the next few years, we expect our current fossil fuel that is used for majority of the ships, this will have to reduce significantly within this decade itself. So as you can see, we expect a significant drop in the use of fossil fuel. And then that will be covered initially by natural gas. The one in gray here is LNG mainly, by natural gas, but can also be LPG. And we expect towards the end of this decade, 2030 onwards, that we can start to see the uptake of low carbon fuel. So low carbon fuel I mentioned earlier could be the green ammonia, green hydrogen, and other electrofuels such as e-methanol. So this is a drastic change with regards to the fuel that shipping will use within the next 3 decades. And this figures is a reflection of the IMO ambitions that shipping needs to decarbonize, reduce greenhouse gas emission by 50% by 2015, the next 30 years. So this has to happen for the IMO target to be achieved. And then in terms of what does it mean for the shipping companies? we have seen that we are moving towards that trend. This graph shows, on the left side in terms of the alternative fuel, I think in terms of the current ship in operation, you can see then that it's very, very insignificant. It's even less than 0.5%, currently ships that are in operation that's running on alternative fuel. But when you look on the right side, these are the ships that have been ordered for yachts to be built, whether they are in Korea, Japan, or China, that close to 10% of ships that are are being ordered as a total are running on alternative fuel. And what we can share is then that as of 2020, the year, just 1 year by itself, we have more than 20% of the ships being ordered are using alternative fuel. So we see then that if you remember these slides, right, that we are moving towards natural gas and subsequently others here, but mainly natural gas. Those trend is something that's already happening right now. And we expect this trend will continue to grow in terms of the use of alternative fuels such as LNG. Because for LNG, one thing is certain is then that the supply infrastructure is available now in various parts of the world. So it's no more an issue in terms of chicken and egg, whether you must have the LNG supply for bunkering versus the demand. I think that was something that probably being discussed maybe 5-10 years ago, but not anymore. Now, a ship owner, when they buy, they know then that the certainty then that the ships can be bunkered with LNG fuel. So that's why we continue to see increased number of LNG, and batteries mainly are for hovercraft or short sea sectors such as ferries, or potentially in the future, next 10 years, could be even container feeder to be run fully on battery. Okay, I think this topic, of this conference is about collaboration, and I will share with you a few case studies of successful collaboration. And collaboration indeed has to happen, because for you to meet the IMO targets, which is really ambitious, 50% greenhouse gas reduction within the next 13 years, that each individual company on their own would not be able to achieve this target. So you need the ecosystem, or you need everyone in the value chain. And here, one of the most successful program with regards to the collaboration within the shipping industry is the Norway Green Shipping Program. For Norway to establish as one of the world's most efficient and environmental friendly shipping. And if you look on the right side here, right, in terms of the different fuels, start, for example, with R&D and piloting, and then you can start it towards inland ferries, and subsequently for coastal or short sea, and then you go for deep sea. LNG started here in the year 2000. So that was just slightly more than 20 years ago. And now it takes, as I said, 2 decades, 20 years for LNG, from the first ships, running LNG as fuel for a non-LNG carrier, until LNG now become a mainstream fuel worldwide. So it takes 20 years. And so you imagine then that IMO wants to reduce the greenhouse gas by 50% in 30 years. So it means then that the rest of things that are being piloted or being proof of concept, stage here, it has to move a lot faster towards here. Because LNG by itself will only reduce greenhouse gas by 20 to 25%, and not more than that. So that's not enough to achieve the IMO target of 50% greenhouse gas reduction. So you need better solution, more solutions compared to LNG. But of course, for LNG itself, there's possibility to reduce further by having bio-LNG to drop in, into the fuel, so that you continue to reduce your emission, right? So here a reflection of in Norway how they have worked from the R&D and piloting, looking at short sea, or looking initially at the fjords, and then moving into coastal, and then you continue to go into deep sea. The process they've gone through. So this program actually has been initiated by DNV back in maybe 7-8 years ago, and as of now, this program has 50 private companies and organizations, as well as 10 governmental agencies. So you can see then that almost everyone within the maritime value chain, plus government bodies, are into this type of program, because they know then that just the shipping sector on their own will not be possible. You need to have the OEMs, you need to have other governmental agencies like the land transport. For example, SINTEF is this university that do I would say RI Research Institute that do a lot of research within the maritime side, and as well as other bodies, right? So you need this type of collaboration, in order for you to be able to move, and get the entire industry to decarbonize. And on the broad approach, how this green shipping program, how do they collaborate? First is then that they do feasibility studies, because before you start to make a decision on investing or even go on your pilot, you need to do feasibility study to see then that technically it's possible, that you can do it safely, and then in terms of infrastructure as well as in terms of the economic viability. So all that normally gets covered within the studies. So then you know what are the incentives required in order for you to proceed from a feasibility study into pilots. So then it's about pilots, about demonstrating, then that it can happen. And then it's about how do you scale up, once you have worked on a pilot, for example, like the LNG, initially starts as studies and as a pilot, and then it will scale up. Similarly with battery in Norway, it started as, as a pilot. Now battery electrification is happening in different parts of the world. But now they are looking at other things like hydrogen fuel cell as well as green ammonia. So it is a continuity in terms of the process. And the next slide here is then to share, right? I mean, by having such a program involving 50 partners, with other 10 governmental organizations, that they have, reflected here in terms of some of those activities that are in progress, like autonomous ferry. Actually, this autonomous ferry is something that's being discussed, but in terms of autonomous cargo vessel and zero emission autonomous and zero emission container vessel, it is in the waters in this week, actually, in Norway. So Norway will start first running this container feeder, about 100 over TEU. Initially, it's going to be zero emission, and they will test all the autonomous capability. We expect within 2 years that vessel going to be unmanned. Okay, so this is how the process starts. Right? I mean, they have feasibility studies, make sure that the safety, the regulatory side, things like that, and then starting, pilot it, in a small scale, and then implement that, and then they expect then that to be the norm, because the Yara Bikelen, that is the first project that I mentioned, that was, there's a lot out there in the news. But the next project where the ship is already being built is AXO, another container feeder that's going to be zero emission as well as unmanned subsequently within the next few years. So the ship is currently being built in Cochin Shipyard in India. So this is a reflection of, in terms of all the activities that are happening within, working within a collaborative landscape. So this is happening in Norway. And then if you look at this part of the world, how do we make, collaboration to happen? And as DNV, we believe that collaboration must involve all the key stakeholders. This project, we call it the Green Corridor, the transportation of iron ore from Australia to North Asia. And in this joint industry project, we involve upstream the cargo owners like BHP, like Rio Tinto. So they own the cargo, okay? And then we involve the gas suppliers like this Shell here and Woodside. We involve the ship designers as well as the ship owners. So everyone that requires to be there to make the value chain, to be possible, that is part of the joint industry project. So here an image at DNV office where we did the final presentation. That was sometime in 2018 actually, when we completed the project. And few months ago, there was an announcement that BHP awarded, 5 ships, to EPS in Singapore to build this LNG fuel vessel, and then BHP, award the LNG supply contract to Shell. So it's a reflection then that, having the ambition, what you want to achieve, getting everyone together, coming up with a plan, So now actually the first ship is expected to be in the waters in the next few weeks. That's going to run this Newcastle Max from Port Hedland in Australia to North Asia. That's going to be running on LNG. So this is a reflection of bringing from feasibility studies to a joint venture project into a reality. And another big announcement that was made here in Singapore just in the past few months is about the establishment of the Global Center for Maritime Decarbonisation here in Singapore. Because again, it's about collaboration. And here, MPA, not just themselves, but they also bring in some of the leading players within the maritime value chain, including like BHP, one of the world's largest commodities company. Other shipping companies such as BW, Eastern Pacific, as well as ONE, one of the world's largest container shipping, with a shipyard and with our DNV Foundation. And totally they will invest 120 million Singapore dollars in the next 5 years. So then that they can come up with programs, come up with initiatives, come up with pilot for the industry to decarbonize, and not just looking at the players in Singapore, but looking at having a global impact. Like what I mentioned earlier, I think this requires everyone within the value chain actually to work together. So this is a major announcement, and I would think that in this part of the world, in Asia Pac, this will be key to get every stakeholders to be involved in the transition. Another example of where through R&D funding by MPA and the Singapore Maritime Institute, they put in about close to $8 million for looking at implementation of electric vessel supply chain within Singapore environment in the next 3 years. So here, as I said, they put in the funding money, consortium come together, and one of the consortium that has been selected is a consortium led by Keppel, which DNV is part of the consortium, that involve the universities such as Irion and Envision and TCOM. These are all research institutes in Singapore. A ship owner-operator, Enghub, as well as Subana Jurong, the infrastructure consulting company. So we bring different stakeholders in order for Singapore to move from currently most of these assets running on diesel to be in the future going to be using batteries. So this is another example of getting the industries together. So to sum up on the aspect of alternative fuel, is then that this is something that whether we like it or not, we expect to see a rapid decline and phase out fossil fuel by middle of this year. Like what I show you in the graph, we expect to have a steep a gradient down, because there's a lot of regulation and there's a lot of forces that require shipping to significantly reduce its emission. We see the alternative fuel on synthetic gas or synthetic liquid fuel and green ammonia. They will be compete. We do not know who will be the clear winner, but we expect to see the world will have a multi-fuel environment. But most of it would require a hydrogen production pathway, the green hydrogen, and through that you can actually coming out with some of these clean alternative fuel. And you can see the statement there, collaboration is key, that everyone in the industry needs to collaborate. So this covers in terms of the alternative fuel and the need for the shipping to decarbonize and how the industries collaborate. I will cover in the next few slides, which I hope to be interested, of interest to the audience. It's about how research institute, universities, OEM can work together to an open simulation platform, because then this allows for you to test out, right? I mean, how let's say the shipping, new building industry works, right? After you have designed the ship, at the moment, and shipping, unlike aviation, where you only have a few designers and a few manufacturers, a handful. Of course, the biggest is Airbus and Boeing, right? But in shipping, we know then that there are hundreds of shipyards. There are hundreds of equipment on board, So the industry is really fragmented. And how do you test out that everything works? Normally, then that after the ship has been built, then of course you do some of these call it sea trial, right? And then based on simulation, you would if your own equipment needs to test out with others, you have to somehow come up with some sort of ability to do that, which is not available right now because the industry is so fragmented. So about 5 years ago, 4 entities in Norway come together to come up with this vision of a simulation platform that can allow the future a collaborative digital twin. Okay, so NTNU is one of the top university in Norway that produce a lot of engineers in the oil and gas and maritime. SINTEF, they are Research Institute, and Kongsberg, I hope all of us know them, and DNB. They come together to help to solve this challenge about, how do you design in the digital and then commissioning it also, in the digital way, in the simulation, and then to run it as operating a complex system. And this within a simulator platform. So that was the concept that these four entities come together about 5 years ago. And after they have come up with the concept, they have come up with initial. There are other members then start to join. So these other members are, you can see some of them are shipyards in Asia, but a lot of them are European. Also, you have Equinor, that is the charterers or the cargo owners in Norway. And then you also have, as I said, entities such as Inmarsat that looks at the connectivity, right? So the grand vision is then that to have a digital twin, right? And a digital twin also create as a co-simulation platform for people within the industry to be able to use it. For example, it can be I mentioned the designers, the OEM, the system manufacturers, the integrators, the yard ship owners, operators, right? But also for academia and research institute. So that is what the vision of this open simulation platform that are, allowing understanding of the entire life cycle with regards to this the ship, because now a lot of ships are coming with not just IT but OT capabilities. So having a platform to test it out even before you build it, is something that the industry already needs, see the need a few years ago and now come to reality. So this is an example of a real project that has then used this platform, open simulation platform, to manage complex system integration. And this is a ferry that they want to test it out. What if you incorporate a battery hybrid, within the battery? How does the future system looks like? Okay. So this joint industry project is like I said, the Diamond World Factory. So the intention is really to plan or to test out this battery hybrid propulsion. That is the pain point, or that is the solution that they want to see, right? How do you test it out in a simulated environment? So then it gets set up. So then it looks in terms of from the design side, but also not just design of the ship, but also optimal design of the generators and batteries. And then for you to be able to do that, then you need to have a library that you can then incorporate some of all these elements coming from different stakeholders, right, into the model. Okay. So by doing this, then that what you expect the product to be. So instead of the previously when you commission to CTRL, that there's always a learning, but here you can simulate it. You can see to make sure that your commissioning will be efficient, and the integration of the battery management system as well as plant management control. But what is key is on the right side here. Okay, it ensures a secure collaboration space, protecting the IPR of all the individual OEM, right? Because OEM, of course, they cannot just give in all their design and their IP out, right? But the platform allowing them to keep the IP out, but then allowing then others to collaborate with them, and then they see how the thing will work. So it is something that can only be possible if you can share your model in a safe and secure, such that you can collaborate. Each one of them can collaborate, but at the same time, they are protecting their own IPR. So this is what the proven with regards to working on this project. So then it allows for on the operation side. Then it allows also when you need to do some of this software update, and then it also allows then scalable simulation on multiple scenarios. Because having the platform, then it really allows you to do that. And we move then from this open simulation platform into now a production environment. We call it the Simulation Trust Center. And Simulation Trust Center is available for people to try out to use. At least at the moment, it's something that you can register and then you can use it. And we are now talking to few universities to use this tool. So this Simulation Trust Center, as you can see here, it allows this digital collaboration space, right? Having the various simulation model with their own functional mock-up unit. So you allow this simulation based on, as I said, the condition and based on the equipment and the asset that you want to use. And then they will then go to the library. From the library, then, you pick it up some of the other equipment that are within the library. And then you can run the simulation and then you can create the results. So this is something that fresh, I would say, outcome from the Open Simulation Platform that it moves into this Simulation Plus Center, and at the moment is available for the academia, research institute, and the industries to start to collaborate. So this then will be my last slide. We see, this is a decade of transformation. In DNV, we call it the Maritime Renaissance. It is emerging. And within this transformation, we see the power of digitalization, especially post-pandemic. The COVID-19, at least in my own experience, indicate then that the mindset of the shipping industry have changed drastically. I give you an example, right? In DNV, for example, instead of getting our inspectors to go on board, in 2018, we have actually tried out remote survey. That means instead of physically the surveyor or inspector go on board, that you can use digital tools to do the inspection remotely. That was already started in 2018 to be pilot, and then 2019 we scale up, and then COVID happened in 2020, right? In first quarter 2020. So by then, by middle of 2020, we have already done 15,000 remote survey. Because the world, you cannot move, you cannot travel, you cannot go to the ships, but you need to ensure that the ship is still safe. You need to have that assurance of seeing then that things on board are still, meeting to all the regulatory requirements. So how do you do that? Is through remote means. And since we have started that journey in 2018, even before COVID, right? It is quite an easy transition for us compared to the rest of them. And there was a lot of resistance, a lot of skeptical about remote survey in 2018, 2019. But now, it's accepted as the way forward. So that's what we mean by the COVID-19 really turbocharged, the digitalization, because the mindset of a lot of people have changed, and that it's possible to do a lot of things remotely through technology. And with that, we also see then that within the industry, because the need to achieve this very ambitious IMO target, that there's a lot more openness in the industry to collaborate, and to be open. That allowing also innovation to their own companies R&D, but also bringing in startups, to challenge the old ways of doing things and showing that it's possible to do it, in the new ways of doing things. And then the other part is collaboration here. You can see that, collaboration, not just within the industry, but also to involve the universities, research institutions, the tech giants, as well as startups. So this is something that we've seen. We expect this to continue extensively within the next decade. Thank you very much. Any questions from anyone?
Okay. Thank you very much indeed, Dr. Osman. A very interesting and very comprehensive presentation. I like that very much. I hope that there will be some comments and questions for you. I invite audiences to ask questions to Dr. Osman. Please, yeah. I do see that you have taken a very significant step toward this collaborative efforts, especially in doing the digitalization and also this digital twin that you say. Yeah. I wonder if there's any Indonesian institutions involved in your project, while waiting for the questions from the audiences.
Sure.
Please.
For that particular project, we have not seen any participation from not just Indonesia, but no entities from Southeast Asia have participated, unfortunately. There are some key players from North Asia, like from Korea, and the rest of them are mainly European and Scandinavians. So, but nevertheless, since the digital twin, this simulation platform have moved into production, it's possible to try it out to our platform. What I can do, I can send the link for people to register and to try it out, because now it is still at this stage where we would want to get participants to use it without the need at the moment to pay for any license to try it out. So we are already, however, now we are in discussion with a couple of universities here in Singapore that would want to use that digital twin simulation for the students as well as for their own research activities. So we expect this to grow in 2022.
Okay, thank you. Is there any questions and comments from the audiences? Let me ask you again then. What is the main suppliers of the batteries that you are talking about? The batteries?
Yeah, in terms of the batteries, indeed, there are various suppliers. We've seen, of course, one of the more prominent that have produced, let's say, batteries for the marine, specifically for the marine, is Corvus. They are initially based in Canada. After that, they moved to Bergen in Norway, because that is where, as I said, there is ecosystem to look at hybridization as well as electrification for the vessel.
Okay, there's a question from Mufti from Polytechnic Batam. His question is, why are the construction and fabrication not considered in digital twin technology? So you don't do any digitalization during construction and fabrication, you don't? Please.
Yeah, of course, the process of digital twin would start before that, right? It will start during the design, stage. And for that design stage, if you know that the process about shipbuilding is then that you will then, design in a 3D software, and then you will send it for approval by, let's say, by the class, that normally comes as a PDF 2D, and class will review and then send it back to, in 2D. And that also we are moving into 3D, into a common standard, irrespective of the software. That ability for the designers, or the builders to send to DNV, let's say in a 3D format, and then for DNV to review in 3D, and then giving our comments back and send the file back in 3D, right? So of course, then with that, it reduces a lot of manual entry at both sides, to work from 3D to 2D and vice versa. And of course, during the construction, the asset needs to be built. And I think on that note, we have shared also our perspective about the possibility of do more modular design and modular construction. That means you build, the asset, in modules, and then you put them together. So that then allows a high level of standardization, right? The standardization hopefully will ensure that you reduce the cost and increase the efficiency, and also to some extent level the playing field. And the future, the possibility of using digital means for doing the construction fabrication is also possible to remote, call it remote inspection. So that's something that we are working on pilots. Remote, let's say, inspection for that CMC or certification of machinery and components, to do it remotely instead of the need to be physical, as well as then the ability, for example, using AI to look at some of the construction activity, for example, the NDT or non-destructive testing in terms of the welding. So it is something that continuously, being researched and coming out with a solution so then that the whole process can be a lot more efficient, safe, as well as, it is supposed to be done to be more effective.
Okay. Is there any questions and comments, please? Okay. Any other question? I was rather surprised with your statement about having this remote survey, because we are trying very hard in Indonesia, at least, not to have a false documents because of this remote inspection. So that needs a lot of effort in terms of installing sensors and cameras and so on board. So you cannot do it in a rather old vessels, do you?
Yeah, it depends on the phase of remote can be really extreme, right? I think if the future of digital twin, then that remote kind of technology has to be installed during the new building stage, where you install sensors not just on the machineries and systems, but also on the hull, which is also something that we are working on. And then through the effects of the ship sailing, that the weather part also we can capture, through this digital means that you could then predict in terms of the ship's condition. Of course, then that will be validated with some of this selected inspection regime. But if to do a remote inspection of a current asset, all you need actually is to have a handphone that can be connected, to a Wi-Fi on board. Then having a software that, there are few available software, and we use one of the software to allow the person on board, to go around. And from there, we have our control center that works 24/7 that can do that survey or review remotely. So like what I say, I think now has been done for more than 20,000 time. So it's a matured, we see that it's already a matured process in place. Yeah.
Okay. This is the last question from Melissa. In some cases, innovation are not in line with the law. Should innovation, especially coastal and ocean innovation, follow the rules law that are already exist, or it should be the other way around, where law is adapted to the innovation?
Yeah, a good question. Yes, very good question. I think there are two elements. Number one, sometimes the law is the one that generate innovation. I'll give you an example. That in Norway, they set a requirement that by 2025, all vessels in the Norwegian fjord, like ferries or hovercraft, things like that, have to be zero emission. But they do not tell you how you want to make it zero emission. So they leave it to the industries, to the university to come up with solutions. So that is where you come up with fully batteries, or you can come up with hydrogen fuel cell, or can come up with ammonia. Right? So then you allow the industry, with the universities, with the institution to work together to come up with a solution. And that is being driven by the law. So innovation, because the law forces you to come up with a solution. But on the other hand, indeed, for example, on autonomous unmanned ship, all the regulation would require then that the ship needs to be manned with, let's say, the captain, the chief engineer, a second officer, those sort of thing. So the law do not allow you to operate unmanned, but it requires you to have resources on board, right, to man. So when that happens, I think the process of innovation is to shape the way forward with the right procedures, the safety requirement, and involving the regulators in that process. So what does it mean? That having like joint industry project that not just involve the technology suppliers, the asset owner, but also the regulators. So in that case, in Norway, the Norwegian Maritime Authority are involved in the project. Similarly, like in Singapore now, several of the projects, the Maritime Port Authority are involved. So they are prepared for this new future. and then they will then need to make the adjustment to the regulation to meet to this new future, or it is forcing or it is requiring then that part of the innovation to come out with call it a technical requirement or recommended practice or process and procedure, the standards that subsequently the industry will adopt. So you need to always push the boundaries and not let the lack of regulation or the stringent regulation to stop innovation. But the thinking through what the industry needs, what the world needs, and coming up with the right solution, but then working together with the regulators, to get them on board. I know maybe in Indonesia it's easier said than done, but to me there's no other option but to create that awareness, engage the regulators, and get them involved, and get them also find out what are their concerns in terms of whether safety or anything, and then resolve the concerns by doing feasibility studies or safety studies, and then present it to them, right? So then you avoid them stopping the innovation to happen because of whatever other concern that you may have.
Okay, Melissa, you want to ask again? Melissa, are you going to ask Dr. Osman again?
I think it's enough, sir.
Is that clear?
Sir.
Okay,
Yes.
okay.
Thank you so much.
Good. I think we have come to the conclusion of this session. I would like to thank you, Dr. Osman, for a very interesting and enlightening talk for us today. I appreciate your availability to provide your views to us. Please give applause to Dr. Osman. Thank you.
Thank you for the invitation.
Yeah, thank you. I will contact you later on. Yeah, okay, thank you.
Thank you.
Please open for a photo session. Please open the camera for the photo session. Pak Iqbal sudah di sini bersama kita, alhamdulillah. Ya. Saya tidak dengar nih, saya tidak dengar suaranya. Sudah lanjut. Oke, lanjut ya. Well, we are going to continue our next keynote speakers. The next keynote speaker is Pak Iqbal Fikri. At present, Pak Iqbal is the production director of PT PAL Indonesia. Pak Iqbal is a graduate from ITS. And now he is the rising star in PT PAL, I think. Previously, he was in the PT BKI. Now he has been involved in lots of projects in PT PAL. And we will talking about the how do we proceed with the a more sustainable future by within the blue economic context from the perspective of maritime industry. Yeah, Pak Iqbal, you have 45 minutes of presentation, and then it's followed by 15 minutes question and answers. Yeah, please, Pak Iqbal.
Thank you, Professor Daniel. He's really my guru in ITS. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I would like to extend my appreciation and thanks, my deepest thanks to Professor Daniel and Rosyid, and also the organizing committee of the 9th ISOCEEN 2021 for inviting me as one of the speakers in this very prominent conference. Let me introduce myself. My name is Iqbal Fikri. As had been earlier mentioned by Professor Daniel, I'm now the production director at PT PAL Indonesia Persero, one of the state-owned company in Indonesia. And I would like to convey or to bring the topics of opportunities for collaboration in Indonesia blue economy, and this is the perspective of maritime industry. These are my outline. The first part is the blue economy and role of maritime industry. I would like to provide us all the description of the blue economy and what is the role of maritime industry in the blue economy itself. The second part is the PAL Indonesia as maritime industry. I have to bring up this topic in order for you all to understand my point of view as PAL Indonesia and as a part of the maritime industry in blue economy. The third outline is collaboration and the potential and challenges of Industry 4.0 in Indonesia. I would like to make a relationship between the potential challenges of blue economy and how we can make a bigger impact by the intervention of technology. The last part is the outlook and conclusion. This is the introduction of the blue economy. In 2010, the concept of blue economy was introduced by Gunther Pauli through his book entitled The Blue Economy, 10 Years, 100 Innovations and 100 Million Jobs. This book inspires a concept that seems to invite the global community to change the paradigm of how to manage natural resources optimally, wisely, and sustainably. Gunther Pauli's blue economy concept tries to offer a solution to address the challenge that the world economic system tends to be exploitative and has actually damaged the environment. The exploitation of these natural resources has exceeded the existing capacity or the world carrying capacity. So after 2010, this concept had been examined by many parties, including the World Bank, European Commissions, United Nations, and they put different description to blue economy, but however with several similarities. The first is blue economy is very much an ocean-related economics. Blue economy talks about sustainable use of oceans, and it covers tourism, mining, port, shipbuilding, transportation, and etc. The pictures that displayed on the screen is the description of the blue economy by the European Commissions. European Commissions or EC states that blue economy involving many sectors, including aquaculture, fisheries, coastal tourism, shipbuilding, and repair. And this is exactly my sector, maritime transport, oil and gas, offshore wind energy, and so on. So these three highlights or points, main points of the blue economy is ocean-related economics, sustainable use, and covers many sectors across the maritime sectors. We can see as the background of the blue economy is the information on the global and national economic development. The economy in various countries in the second quarter of 2021 has increased. This is indicated by the PMI index, which shows increase from 50.4 in June to 50.8 in October. The economies of several Indonesian trading partners in the fourth quarter of 2021 also shows positive trends. We can see the economic growth of several Indonesia's trading partners, namely China, USA, Singapore, Hong Kong, and European Union in aggregates in total. So if we see the economic development percentage year on year in Indonesia, also we see the second quarters, it has been rebound to 7% from previously minus 0.71. Blue economy can take its part as powerhouse of Indonesia economic development. This is a statement by the Indonesian president in 2016 that Indonesia has a sea area of 70% of its total area, but the contribution of maritime sectors to the national GDP is still below 30%. We see the potential use of maritime sector in Indonesia in energy sectors. We have to really overcome, and we can see the potential, the tide energy, also the sea heat and wind energy in Indonesia. How about the tourism potential? Indonesia, we have 6 of the 10 best marine ecosystem in the world. We have second longest coastline in the world, and Indonesia is also very famous for its diving sites. Fisheries, I cannot say more about the fisheries. We have a very big potential for fisheries, including not only aquaculture but also the catch fisheries in the sea, on the sea. We also find that the marine biota for medicines, we have 35,000 species, which has potential to be used as medicine. How about the BMKT or barang muatan kapal tenggelam? This is the treasures from ships, wreckage. We can see around 700 to 800 points that ship wreckage that have potential economies. Mining, oil and gas, sea sand, minerals. This is not only oil and gas, but also the mineral resources. And the last part is the maritime industry. The industry that I'm currently joining is national shipbuilding. The national industry had been trusted to build 126 units of vessel, contract value of 10 trillion rupiah. And if we see the blue economic potential of Indonesia is very massive. Every year, around 88% of the world trade passes through the Malacca Strait, Sunda Strait, and Lombok Straits. This is the potential that is still on the progress of developing. What should we do with this? Because this is still potential. What should we take on as charges or fees for those ships, vessels passing to Indonesia? Indonesia's maritime economic potential itself consists of 1.33 trillion US dollar per year. So still the question of potential is still potential, and what should we do with the potential itself is very much the $1 million questions. What had been done by the government? The most I think the most progress or highlight that we can discuss is the Kawasan Ekonomi Khusus or KEK, Special Economic Zone. If we take a close look at the Kawasan Ekonomi Khusus in Bitung, this is very much a model for the development of blue economy with the approach of the special economic zone. Bitung is very much famous for its fisheries industries, but also for its transportation significance in East Indonesia to the north of Indonesia. We see the Bitung Fish Port, International Port, and the infrastructure itself. We see a massive development built by the government. The zone itself is divided to the logistics zone, warehousing, trade center. This is a supporting for the industry of the coconut, pharmacy, and fisheries. This is the really very much a model that we still see in upcoming years the success of this concept of economic zone, special economic zone in supporting the blue economy concept. What is the strategic role of maritime industry development? If we see the big company, let's say the automotive industry, Samsung, Hyundai, or previously in Japan, Mitsubishi, most of them, they really started as a maritime industry, as a shipyard. This significantly implies us that maritime industry involving very much high intensive technology, not only the platform or building the ship as a construction building or platform, but also it involves the mechanical, the machinery, the electrical, electronics, control, and many aspects of engineering that supports the building of ships, then supports the big industry to join to the more simple technology or products such as automotive. So industries with intensive technology is a maritime industry, significantly important in assessing the strength of national defense, economic development, and development of other industrial sectors, such as steel industry, electronics industry, and machine industry. This is the strategic role of maritime industry. This is the maritime industry profile in Indonesia. In Indonesia, we have around 250 shipyards, which is a pity that more than 80% of the shipyard is located in the western part of Indonesia. If we see the potential of the blue economy, the fishery industry, the movement of goods and people in East Indonesia, of course, this is very much a potential of business development of shipyard industry in the east part of Indonesia. This is the industrial capability of national shipbuilding industries, both in ship repairs and the new ships. If we see the capacities held by the Indonesian domestic shipbuilding industry, we see a gap. We see a gap of having to fulfill the demand and the capacity, existing capacity of shipyard industry in Indonesia. We see a growth demand of replacement of existing old vessels. And we see also the demand of building the new vessels because the economic development. So we see a gap which is also shows a potential business exactly for the shipyard industry in Indonesia. These are the constraints and challenges of shipyard business. The first constraint and challenge is the market share and order certainty. Despite the potential that had been mentioned earlier, there is an uncertainty on procurement in taking care of the captive order and captive market. The technology license and production technology, most of the technology products, services that are imported from the foreign countries, they are protected by the technology license, which is highly regulated by the principal country, causing us, Indonesia, in the condition of the state of dependence on principle. How about the infrastructure and human capital development? We have challenges of technological capability readiness in delivering the quality, cost, and delivery of products. How about the supply chain? This is also have very much constraint in us related to the percentage or proportion of the import of products and services from foreign countries. R&D investment, even though this had been shows like a silver lining that by the establishment of BRIN, the Badan Riset and Inovasi Nasional or National Research and Innovation Agency, still R&D is mandatory for the new product development, and this is a very high capital intensive, and it is not very easy to possess or taking the new technology which is controlled by the copyright and protected by many boundaries of having it to be produced in Indonesia by ourselves, by the domestic industry. The key success factor is the synchronizing the, this is related to the military product and development of national power, minimum essential force, MEF. But in the commercial new building, the national financial support, the budget, and roadmap of industry shall overcome the uncertainty of the captive orders and captive market. The FDI or foreign direct investment shall be promoted to protect intellectual property right of the principal, and as well as to promote investment of high-tech company. Human capital readiness and the constraint and challenge can be overcome, at least remedied by the cost sharing, production sharing, and the global supply chain. Due to limited budget, time, and resources constraint, the quad helix concept, collaboration among, this is the topic of this ISOCEEN 2021, the collaboration among academic institution, maritime defense industry, government, and user should be implemented. I would like to take a very short or a brief introduction of our industry background as a maritime industry, which is PAL involved in this sector of maritime industry. PAL is fully owned or 100% owned by the government. We are located in Surabaya, in East Java, and established in 1980. In naval ship products, we have a portfolio of new shipbuilding, of maintenance, repair, and overhaul. And the most recent one, we are the only one of the maritime industry which is involved in the submarine production and MRO. In the commercial ship and general engineering product, we produce many types of vessels involved in oil and gas, mineral resources by producing the onshore floating production unit, and the most recent one is the floating barge with BMP or barge mountain, which is scheduled to be delivered of 2021 to Ambon. These are the research vessels built by PAL Indonesia. The geometry Hello, so sorry for the bad connection. Prof Daniel, ini
lanjut Pak Iqbal, silakan. Baik, Pak Iqbal.
Bentar.
Pak Iqbal. Belum selesai kan? Silakan Pak Iqbal. Tapi belum masuk ya? Masih jelek ya koneksinya? Silakan Pak Iqbal.
Professor Daniel, can you hear me clearly?
Yes, I can. Very clear. Silakan Pak Iqbal. Yeah, please. Yeah. Proceed.
Maaf. Please apologize for the bad or poor internet connection.
Okay. Yeah.
Okay. This is the latest one of collaboration made or established by industry and also the research institution in Indonesia. This is the Tsunami Early Warning System, which is a collaboration between the PAL and the BPPT. We built the Tsunami Early Warning System and already deployed, located in the 13 locations. And this is the collaboration in form of a consortium across the body of the research and also the body of innovation in Indonesia, consisting of the materials, testing of model, testing of mechanical strength, capacity and performance of this tsunami early warning system before they had been deployed to the across location in Indonesia. And this is the collaboration and also the implementation of the collaboration that had been mentioned earlier about the quad helix concept. We see that the scheme of collaboration model in order to boost the blue economy had to be established. And this is the model that had been run by PAL and also the other supporting industries. And it involves the government as the policymakers and also the government sometimes as users in the form of the users of the military and the non-military product. We have to make a collaboration itself also across the university and academic institution, including the National Research Institute. Is it possible to make a collaboration without the supporting industries in Indonesia, like components, like steel industry, electronics? It is very much impossible. So I think this model scheme of collaboration need to be developed in order to boost the blue economy in Indonesia, not limited to the maritime industry or shipyard industry, but also need to be developed across the fisheries industry, mining industry, the tourism industry, in order to boost the blue economy. And in order to have a bigger impact of the blue economy, it is impossible not to invite the technology to join or intervene with the development of the blue economy. The development of blue economy will involve of industry and advancement, technology advancement, and now we already discussed a lot with the Industrial Revolution 4.0, which involves IoT, Internet of Things, big data, artificial intelligence, and advanced robotics. If this issues seems to be so far away from the implementation, I have to tell you that it is very much closer than we think. The development of the big data in Indonesia is influenced by the development of big data in global world. There are two main factors that will lead the development of big data at the global level. The first factor is the massive increase of the volume of data generated. The second factor is the support of the development of big data by increasing the electronic computing capacity. We see this had been two factors in global, but also exactly these two factors also happen in Indonesia that lead to the development of the big data. Opportunities and challenges of AI development in Indonesia, I have to very much put a highlight in the human resources development apart from the technological development.
It's 14:30.
Because the human is the center of the industrial development in Indonesia. The challenge is the qualified capabilities in processing AI, also the high cost of AI-based data processing programs. There is also a technology risk of data privacy and security. And this is the model of collaboration that is still undergoing in Indonesia and promoted by PAL. We see, as I have informed previously on the previous slides, that there is a gap in supporting the blue economy development, specifically in fulfilling the gap between the demand and also the existing capacity of Indonesia shipyard industry. We see that to compete among shipyard companies in Indonesia is very much taking high energy on us, and this will not really much benefiting of us compared to contribution or impact that we have if we collaborate with each other. Therefore, PAL put forward the modern multi-yard 4.0 concept, which is which gathers the demand of building the vessels and other floating objects in Indonesia to a platform which is shared together. So this will not really much talk about the competition, but this is very much increase to our together resources, the shipbuilding and maintenance in Indonesia. It is expected in 2022, this modern multi-yard concept, which standardize the business process, the shipbuilding standards, the human capability standard into one platform will bring us stronger. The collaboration will bring us stronger in fulfilling the need of the demand. So the blue economy can be boosted by the collaboration among the shipyard in Indonesia. And of my presentation can be and should be the backbone for the Indonesian recovery during the pandemics and after the pandemics. And the blue economy shows its prospective application. The maritime industry needs to be further improved as an effort to prepare for the Industrial Revolution 4.0. Modern multi-yard concept, which is developed by Paul, is a way of collaboration in maritime industry to boost blue economy. The quality of human resources from the maritime sector needs to be continuously powered by the application of technology and improved innovation. The last one is collaboration in blue economy shows its potential, and even with the aid of technological advances, however, signs of supporting policy literacy of blue economy among the players and the regulators in Indonesia, lack of multi-sector approach becomes the biggest challenges of its success or blue economy success. I have many points to add, but if I can make it short about industry initiative, today's condition, maritime industry really hard in finding its own way to develop the blue economy by itself. Therefore, the incentive and intervention of government will add significant result to the success of blue economy. Collaboration needs to be pushed forward. Blue economy concept itself is to improve not only prosperity, but also the livelihood for the next generation. I think this conclude my presentation, and I would like to having it back to Professor Daniel M. Rosyid as the moderator. Thank you, Professor.
Thank you, Pak Iqbal. A very comprehensive and inspiring talk from you. You have talked about the importance of collaboration between government, the private sector, or the users, and also the academia, and also the supporting industries. I would like to invite audiences to ask questions and comments. Pak Iqbal, there is one question.
Yes.
From Hakindo. Boleh, silakan bertanya langsung. You can ask directly to Pak Iqbal. Okay, let me read the questions. Yeah. As maritime industry, is it possible to support blue energy in spatial renewable energy? I've heard PTPAL has special division to manufacture
Okay.
In energy. You PTPAL is you have a quite significant divisions in energy. Yeah.
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 Okay.
Please. Yeah. Okay. There's one question. Yeah. The second question. Okay. Yeah. I've seen this information of potential about this and that a long time ago, but I don't see real actions. Yeah. The other thing, rather than try to take all potentials, why not focus on one specific item and ensure we can achieve it in a measurable time? Please, yeah, Iqbal. Yeah.
Right. Thank you, Professor Daniel. The first question from Hakindo about the support of blue energy and specifically renewable energy. I have to mention that the most capabilities possessed by the Indonesian maritime industry, specifically shipyard industry, is in production techniques and capabilities. I really have to be frank that the research and development is very much very high intensive of cost, and therefore not all of the maritime industry can afford it. We see the good signs of the establishment of BRIN by the government, which gather all of the resources, not only in research, but also in innovation. PTPAL is very much supporting the establishment of this research and innovation agency, because we also had been offered by the government. If you would like to develop the renewable energy, if PAL would like to develop the, this is quite a sensitive information about the military missile and torpedoes. So you can ask BRIN for the personnel that you need. So I have to inform in this very good occasion that we have a special division, the general engineering, which involved in the electrification, energy sector, which I have mentioned earlier about the this January, we will deliver the floating production with dual fuel engine for producing electricity to Ambon, which can consume diesel and also gas. This is our products of producing energy. So, of course, we see the potential of the tide energy, the wind energy to be located offshore as potential sectors in the future to be developed by the PAL, and not only by PAL, but also the maritime industry as a whole. By the second question by Pak Badlus, I really enjoy this kind of critics that I have seen this information of potential about this long time ago. What you have been waiting for is the real actions. That's why I have mentioned the challenges, because the challenges is not very much easy to overcome. I have to mention that the modern multi-yacht concept is not really a new concept at all. I have to say that this had been many years ago had been discussed, but there should be a willingness to share And the willingness to share the business prospect is not a very easy way to be done. We have an initiative of that. If we see the cake is there. If we want to fight for having the cake only for one, then there is a possibility of missing a lot of opportunities by the others. So therefore, the modern multi-yard, this will be a promise to the maritime industry in Indonesia, that we have to see the challenges and the demand as a whole, and to be fulfilled by all of us. So there should not be a win or lose idea in having all of this demand by ourselves, not by oneself. We have calculated the potential, and if we fight with each other compared to if we collaborate with each other. So this is not a concept which is very difficult to be implemented, because as a business entities, we already see the calculation is very much beneficial for all. So I wish I can answer this by the real fact, but this will take around 9 months to 1 year to see it works and happens. Then I can come again to you, Pak Badrus. Thank you, Pak Badrus.
Yeah, thank you, Pak Iqbal. Yeah, there's another question, Pak Iqbal, by Dina from Dina. Is Dina there? Do you want to ask directly to Pak Iqbal? Dina? You can ask directly to Pak Iqbal, Dina.
Okay. My name is Dina. I'm from Ocean Engineering ATS. My question is, I've ever heard that currently there are many foreign ships that control Indonesian sea transportation, even though Indonesia has a very wide potential regarding sea transportation. So how can we resolve this problem? Thank you.
Okay.
Cukup jelas, Pak Iqbal? Jelas, Pak Iqbal, ya? Yeah, okay.
Very much clear. I think this kind of questions also, I still remember when I was a student that Professor Daniel asked us not to very much or not to only have interest in technical subjects, but also things related to the regulation. So yes, it is very much true that many foreign ships, if I cannot say many, but a number of foreign ships still control or still operating in Indonesia waters. The condition itself is not many of Indonesian ship operators, they have a very good bag of capital to possess or to own this kind of very high-tech ships. Let's say, if I had mentioned earlier, the research vessels, we have very big potential of mining industry in oceans. We have many kinds of minerals laying on the Indonesian seabed, which is still not had been exploited because of the limitation of ourselves to have vessels, the research vessels that really can indicate the potential and the potential of the specific minerals, which is very precious and very big in numbers economically. So these very expensive ships cannot be owned by Indonesian or Indonesia ship operators or ship owners because it's a very high price of possessing that kind of vessels. The second one is there should be a continuous or an exact demand of this kind of vessels in order for the Indonesian ship operators and ship owners to make it feasible in business because of its price, and also there is a lack of continuity, then this will become very difficult to have this as a business. If you already have the subjects of engineering economics, I think you can very much understand about what I intended to say. So, Mbak Dina, this is a very good question. But if it is verifiable in business, then you will see less and less foreign ships sailing across Indonesia compared to what we expect is in more and more, and it is expected 100% of vessels operating in Indonesian waters are Indonesian flag vessels. Thank you.
Baik, Pak Iqbal, terima kasih. Thank you very much indeed. Saya undang, I invite more questions from you. Is there any? Any more questions? Okay. Pak Iqbal, it is well understood that in Indonesia, collaboration is easily said than done. Yeah, we have to work very hard for that proposed, and I think ITS is willing to work closely with PTPAL to make sure that your ideas and PTPAL visions become reality. Yeah, inshallah. Yeah. Is there any more questions? Yes, we have still 5 minutes left. Wait a minute. Oh, there's no more. Okay. And there's a question by Giant Gregorius Sitompul. Gregorius, are you still there? Gregorius? Pak Iqbal, can you read the question?
Yes. Okay. Yes, Professor Daniel. Gregorius Sitompul asks about how PTPAL will join and use the innovation of using the renewable energy as the supply power of ships, and how long the probability of time will take. I think the technology is already available. If we see, this is a very much a simple points or a spark of discussion. If you want to use gas as fuel, and we want to see the ships as those vessels which use gas as fuel need not to be worried about the supply of the gas. I think the most easiest way to have the gas as fuel is in ferry in Indonesia. The ferry which across, let's say, Ketapang and Gilimanuk. The ferry across the Merak Bakahuni, because we only need to supply gas in those points or those 2 ports, Ketapang, Gilimanuk. Merak Bahuni. This concept is need to be detailed, but in simple, this is a very much a simple logics. If we want to have a renewable energy, or let's say a green energy, like gas, to be as fuel, but the project cannot really much control. The cargo vessels may sail to Makassar, to Ambon, to Sorong, and then back to Batam. It is very much difficult to ensure the availability of gas as fuel, supply as fuel on those many ports. But if we can make a project in the ferry ports, let's say Merak Bakahuni, we only need to make a supply or assurance of supply on those two ports. So this project is very much open. I think PT PAL will very much eager to involve this project. And again, with the topics of this year ISOCEEN, this should make not only by PAL, but also in collaboration very much with the government. I don't think there is other hands which is more powerful and having easier way to have an investment or to make spend money other than government, because the business is very much will make a very detailed calculation, and there is a need of intervention by the government in the form of financial or non-financial incentive. I don't really mention about the money or number, but non-financial incentive in terms of regulation also will be needed by the industry. Thank you, Pak Gregorius Sitompul.
Yes, thank you, Pak Gregorius. Pak Iqbal, I think we have come to the end of this session. Unless there's another question, is there any more questions from the audiences? Okay. Before closing, I would like to invite all the audiences to open the camera for a final photograph. Please open the camera. Okay. Pak Iqbal, yeah, please, yeah. I would like to ask the MC to take over the session. Thank you very much indeed, Pak Iqbal. Applause for Pak Iqbal.
Thank you, Professor Daniel, for inviting me.
Thank you, Pak Iqbal. Please stay for a moment for a photograph. Yeah.
Okay, let's take a photo for documentation. I will count 3. 1, 2, 3. Okay. Once again. 1, 2, 3. Okay. Thank you.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you to Prof. Daniel M. Rosyid, Dr. Shahrin Osman, and Mr. Iqbal Fikri for this session. Thank you to all speakers who have shared their knowledge. It doesn't feel like we've spent hours in webinars today, but it turns out we've reached the end of today's event. Tomorrow, there are 4 parallel rooms, different from today. You can choose to join one of the rooms. The link is in your email. Before we close, I remind all the audience to fill the absent link in the chat column, and we will announce the best participant on the next day. Because the event begins with prayers, then we will also end by praying. Let's pray together. Praying begin. Praying is finished. I'm sorry, as Master of Ceremony, if there are any unpleasant words. With this, today event is over. I'm Lutfan Tawil Hafiz, as Master of Ceremony. Say thank you to all participants and see you again in the second webinar tomorrow. Bye-bye.